All right, so welcome to the video, and in today's video we are going to solve this mathematics for first year NS students, ma110. Okay, we are going to be solving the full paper for test 1 for the intake of 2025 to 2026. This is one of the papers they wrote. I know there were like a number of sessions, but I've decided to pick this. I managed to only have access to this paper, so I've decided to solve the whole paper. So we are going to solve all these questions. Okay, so make sure that you pay attention, because and actually this video is meant for two varieties of students. So if you're watching this video, it's either you are maybe studying for your sessional exams, you're trying to revise test 1 or um, term 1. The other variety of or category of students whom I expect to watch this video, maybe it's a student who is studying for test 1 and the first year who is studying for test 1. Okay, so this video will help you to understand how to handle these questions which they brought in the test 1 for 2025-2026 intake. Okay, so without any further ado, and before we even proceed, make sure that you subscribe to the YouTube channel. Right now we are about to hit 2000 subscribers, so make sure that you subscribe to support this YouTube channel so that I keep making more content like this on this YouTube channel. Okay, so this video is going to be focused on solving. I'll be showing you how to handle questions which they brought specifically. Now, whatever I'm going to solve is not, or it is not like what 100% what you need to be able to like comfortably write the test or the final exam. There's more knowledge about mathematics which won't be shared in this video because this is only focused on this past paper. But if you want to learn more, make sure that you download our A Plus Academy app. We have an application called A Plus Academy app. I'll show you I'll put the link in the descriptions, or I'll show you how you can access it on Play Store. So this is the application where you basically find more of our video lessons. Okay, these are videos where we've simplified all the NS topics in mathematics, physics, chemistry, and biology, and we're still adding more and more content. Okay, so on this application, all the knowledge that you need to be able to handle these kind of questions are there on the app. And trust me, the knowledge that I'll use to solve this whole past paper, it has already been shared and more has been shared on the app. Okay, right now I'm just showing you like the summary. So for full knowledge, to be able to handle any question they can bring on the test or exam, make sure that you go on the A Plus Academy app, download the app, install it, and start watching the videos. Okay, so let's proceed. Right, so if you want to access more of our simplified video lessons, come here on Play Store, then search A Plus Academy app. This app here, you can download this app. If you don't have it, then open it. Then after you do that, you're going to create an account and log in. And then on this app now, you're going to find more lessons. So just come here on videos and go maybe on term 3. Let's say maybe you want videos for term 3. You can come here and click any term 3 topic. You're going to see all these videos. And in case maybe you want term 2 work for physics, you can come here and you'll see more videos for momentum and work energy and power. Like everything for A levels or NS work is already on the app. Okay, so make sure that you download the app. And it's not just physics, even these other courses like chemistry, mathematics, everything. These topics, the videos are already here, and physics and chemistry, all these topics, the videos are already here. So make sure that you download the app and subscribe. Right. So let's begin with the first question. So we have question one. So question 1a, it is saying that let f of x be equal to this and g of x be equal to this. Find g of f of x. This is like composite functions. In case maybe you've gone on the app, on the A Plus Academy app, under functions, check for the videos titled composite functions. That's why you find a video where I taught this. So they're saying find g of x and determine the domain. So let's proceed. Okay, so this means that we are going to get this function of g. Wherever there is x, we are going to substitute the function of f. That's what it means. So the function of g is what? Is square root, right? Square root of x. Now, we've said that to find the composite or to find g of f, wherever there is x, we're going to substitute what? This, right? So it's going to be x power 2 over 4. Okay, all right. So now what you're going to do is if you can simplify, if you like the expression is simplifiable, make sure that you simplify. Don't just end here. Make efforts of simplifying, because after this we need to find the domain, and to find the domain you shouldn't have like this kind of an expression. So let's simplify what is under the square root, because it is simplifiable. So this is not negative, guys. I don't know how I wrote that. So we have 1 over square root so let's expand this. This is actually power 2, in case maybe you haven't seen. So we're going to expand this. That's going to be x power 2 plus 1 over 4 plus 2. No, it's just going to be plus x. Yes. Then minus 1 over 4. So use whichever method you use to simplify this. Me, I have a short method. I don't need to do much of the writing. I just solve it from my head. Okay, so now this is having negative, this is having positive, different signs, so they are going to cancel, right? And what are we going to remain with in the equation? In the equation, we are just going to remain with, x power 2 plus x. Okay, so this is our final expression. So in short, what I've just written here is g of f. Okay. So by just reaching here, if the question had like maybe if it had like maybe 4 marks, you've gotten like 2 marks. So to get the full marks now, you need to find the domain. Some of you, this is why you are making a mistake on the test. Or if you're watching this as a first year, was about to write his or her test 1, don't make this mistake. Like I remember, I once made that mistake. Like a question like this one, I'm sure even you who's watching this video can relate. Whereby, after you solve, you also need to find the domain. Some of you rush too much, such that you, like you're in a hurry, thinking that you're running out of time. You forget to find the domain. You just skip in your head, thinking that you've gotten all the marks. Then when you go to your BH, you start passing through. Then that's when you see that they even said we need to find the domain. Me, I forgot. I didn't see that. So make sure that you are taking your time to read the question. Okay, take your time to read the question. Make sure that you read it like twice. You just like take note of what they want you to find. Okay, so let's now find the domain. We get the full marks. I wish I had I wish I was right in the I think I'm going to write the marks so that as I'm solving, I'm telling you that this question had this and that marks, so that at least you are taking me serious when I'm solving. So now, how do we find the domain for this? So if you observe, we are having a denominator, right? This one. That's where the values of x are. And since this is like a fraction, we know that this should not be undefined, right? So this also means that whatever is going to be on the denominator, whatever values of x that's going to be on the denominator should not be equal to 0. Because if it is equal to 0, it will mean what? It will mean that you'll get undefined, right? So now let's find the values of x. So I'm going to raise both sides by power 2 so that I get rid of the square root. Now I have x power 2 plus x, and it should not be equal to 0. So let's solve for x. This is simple, guys. This is basic algebra that you learned in grade 7. So in this situation, just factor out what is common. In this situation, x is common, right? Then what have we remained with? We've remained with this. Okay, so now let's find now the values. So we know that first of all, x should not be equal to 0, right? Then x should also not be equal to -1. I've just taken this on the other side. Like you get this equal to 0, then you take this on the other side. So this even makes sense. If you want, try it. If you put 0 here, you end up with zeros on the denominator, right? That's what we don't want. If you want, get -1 and substitute. You find that you're still going to end up with negative under this, on the denominator, which is what we don't want. So how do you conclude your answers now? So if you are somebody who has been watching the videos on the A+ Academy app, I've showed you like 2 ways, right, in which you express your answer. So the first way is you can say that for all values of x can be real numbers, but they can't be equal to 0, or x can't be equal to -1. Now some find this to be complicated. So if you want, you can write in intervals where you say that the values of x can be from -infinity to -1. I've put this deliberately in case you haven't watched, in case you don't know, there's a difference between using this and using this. If I use this, I'm saying it is not part of the set. This is part of the set. So I've used this saying that -1 should not be part of the values of x. But if I use this, it means I'm saying that -1 can be among the values. Okay, then you say union. Even here, I'll use this one, this symbol, the parenthesis. It's called the parenthesis. These are called parentheses. Okay, so I'll put 0 here, comma. Like I said, this video I'm just solving, but if I was teaching, I would have explained like the logic behind what I'm writing. But you can watch, there's a focused lesson which focused on this one. There's a video which focused on this concept. Under interval notations, I taught this. So check out the videos of interval notations that I taught. Okay, so we've just found the domain. So let's proceed. All right, so we have now question 1b, saying that a binary operation defined on the set of real numbers as follows. You have this formula. They are saying where a, b are real numbers. So the first question is the operation defined on the set of real numbers? And give a reason. So the way that we handle this question is you're going to think of possible real numbers that you can use in this formula. Then when you plug them in the formula, if none of the real numbers that you are going to think of is going to give you undefined, then this then this operation is defined on the set of real numbers. But if there will be a certain a variety of real numbers that are going to give you undefined, then this operation is not defined on the set of real numbers. So let's demonstrate that. Let me show you how to handle this question. Okay, so we have a binary b is equal to a over b power 2. This is the formula given, right? Now they want us to see if the operation is defined on the set of real numbers. So we are going to come up with possible real numbers. So the easiest thing you can do is to view it from the number line perspective. Here is 0, right? So on the number line, the kind of real numbers that we deal with, we can maybe categorize them into 3. The first variety is real numbers which are on the positive side. You can think of any. The second variety is the real numbers which are on the negative side or negative region. Then the third is just one real number, which is 0. In case you don't know, 0 is also a real number. So we have all numbers. It can be decimals as long as it is negative. They are found in the same variety. The other variety is the real numbers which are positive. They can be positive 0. What? It can be a solid number like 2, but it is in this category. And there's just one number which is 0. So we have 3 categories, right? Of course. So you are going to start like plugging. Get any value from each category, just one, and see if there will be any that will give you undefined, then this operation is not defined. So let's start. Let's start from the negative. So I'll get a simple number. Okay, right now I'm just coming up with a counter example. So you can pick any value that you deal with easily. Don't pick 0 point something. I'll just give you an example because you don't use calculators. Okay. So it's going to be let me pick 1. So I'm picking from the first variety of numbers. So I've picked 1. Okay, so okay, let me pick 2 numbers, I think. So I'll pick 2 numbers. Let's say it is -1, it is -2, it is +1, it is +2. So I will let my A be -1, my B be -2. So where is A, I'll put -1. Where is B, I'll put -2, which will give me +1/2. So we are getting a value that is not that is defined, right? So this has qualified. Let's come to this other side. And while testing, if you want, you can like you can mix them if you want. If you want, you can mix a negative. Maybe you can get A like -1. B you can get +1. Okay, but right now let's focus on the negative and the positive values before we come to 0. Or if you want, you can just get actually this is supposed to be, I forgot that this power 2, so this is supposed to be power 2, right? So it's going to be 4, -1/4. If you want, you can pick maybe -1 as your A, and your B you can pick +1. But as long as you pick any number from this and this, you will still get what? You still get something that is defined. I want you to get my point here. So right now we can confirm that if we pick any number as our value of A and B, that is in this region and this region, or that is in this variety and this variety, even if we mix them, because it's not mandatory that they have to be negatives only that we pick. You can mix them, okay? We are still getting a defined value. Now let's come to this category which we haven't used. Let's look at 0. So if I pick my value of a, so I'll use 0. I'll use it either as my value of a or my value of b. So let me begin by using it as the value of a. So if I say a is equal to 0, then I say b is equal to 1. Then I plug in that formula. A I put 0, b I put 1. It will still give me 1 because 1 power 2 is still 1. I'm getting 0 over 1. Now, is 0 over 1 undefined? No, it is defined, right? It is defined. So it's giving me 0. When you have 0 on the denominator, you get 0. Now let's speak. Let me make this to be my b now. Okay, in this counter example, I've just made it my a, and we've observed that it is giving us something that is what? Something that is defined. So now what if maybe I say this time my a is going to be -1 and my b is going to be 0. Okay, let's plug in that formula there. So a I put -1, b I put 0 power 2, which will give me -1 over 0. In this situation you get undefined. So we can conclude that most of the real numbers, like all the real numbers except b being equal to 0, are defined. So since here they specified, they wanted us to see if it is on all real numbers. So we can say that in the conclusion, giving a reason, because you have to give a reason. In the lecture, we'll look at the reasons. This calculation is to just like to prove your reasons. Okay, I think some lecturers don't even want to see all these, but these will help you to come up with a final correct answer. But some might want to see it. Yes, like they just want you to show the work, that especially this part. So we can conclude that based on the above counter example, if you're someone who like concluding properly, you can say based on the above counter example, the operation is not defined on all sets of real numbers, because when b is equal to 0, it is undefined. Or you can say the operation is defined on all the real numbers except except 0 when it is the value for b. I don't know how you're going to phrase the English, but you have to state something like that. So I've shown you. And imagine this at 1 mark. Do you know this thinking for 1 mark? But anyways, this is the non-quarter I wanted. So just enjoy all this. So let's move on to the next question. And these are the kind of questions whereby you just have to apply basic knowledge, because whatever they brought is something that some of you already know. You already know that when you have 0 on the denominator, it means the value is defined, right? Is undefined. When it is defined, it means on the denominator there is no 0. So there's nothing new here. So here they're saying, is the operation commutative? If not, give a counter example. Some people, when they say counter example, they get confused. What is this now? Right. Okay. So let's proceed. So they're saying what? They're saying that is the operation commutative? So when the operation is commutative, it means that binary A and B, A binary B should be equal to B binary A. This means that when you get the expression given, A over B power 2 should be equal to when you swap the letters, whereby where there's A you put B, where there's B you put A power 2. So when you simplify this using any real number, because we are dealing with real numbers, and be careful, read the questions carefully. If they haven't said real numbers in your count example, don't think of using a real number. Okay, and in case maybe you are somebody don't understand binary numbers, like they're not making sense to you, because right now in the videos I'm just solving, not teaching. There's a special video in the A+ Academy app under the Okay, so like you find the video labeled on the sets of numbers, you find the video labeled binary operation. Just have 1 hour. In that 1 hour, I've taught like everything. Trust me, by just watching that video, most of the students ignore it. By just watching that video, I don't think there's a question on binary numbers that you can fail to solve. So listen, there are two ways in which you can solve these kind of questions. It's either you show your work using letters or using numbers. On the app, that video I'm talking about, I've taught both methods. It's either you use numbers or letters to show your work, but that depends with your lecture that you are having. So make sure that you use the method which your lecturer has showed you or which the lecturer taught you in the class, because I've seen situations whereby a lecturer, especially Mr. Sakala, there was a certain intake where he told students that when presenting my work, use letters. But me, the lecturer whom I had, he was okay with using numbers when giving the counter example. But I've taught all those methods, so just watch that video because it's something that's going to be lengthy to explain here. Okay, so I'm going to use numbers because they are more accurate. Yes. So we are dealing with the real numbers, right? So let's come up with a set of real numbers. So real numbers. Let me just come up with something that is simple. Okay, like 1, 2. So just come up with like simple values of numbers. 1, 2, 3. So my A is going to be 1. My B, and put 1. My B is going to be equal to 2. So I'll substitute now in these expressions. So let's start with the left side. So where there's A, I'll put 1. Where there's B, I'll put 2 power 2, right? Then on this other side, where there's B, we are putting 2, right? Where there's A, we are putting 1. So we have 1 over 4 is equal to 2 over 1. Now, I need to ask you this question. Is the left side equal to the right side? Of course not. So we can conclude that this is not commutative. Because if the two sides were the same, after simplifying like this, we would have gotten the same values. Okay, so now let's proceed to the next question. All right, so saying that question 1, they are now on the 3. So question 1b3, they're saying find the values of this and this. And this is the concept on associativity, right? So even here, I've taught this. So the question which you are from solving it at 2 marks. So by just showing that it's not commutative, you've gotten yourself 2 marks. Let's go to another one which is having 2 marks. So we just have to simplify this and this. Okay. So on question 3, saying -1 binary 1, 2. Okay. So now let's write also the formula given. A binary B is equal to A over B power 2. Right. So the way that we solve this one is what I like doing personally. I'll start with what is in the brackets. So in the brackets, I'm having this as my A, this as my B, right? So I'll get this expression. So like I'll say right now I'm solving this one alone. So I've just taken this part alone. Whatever value I'll find when I simplify it, I'm just going to substitute here. So I have 1 binary 2. This is the one I'm solving. So this is my A, this is my B, like I've said. So where this A, I'll put 1, and where there is B, I'll put 2. Okay, so we have 1 over 4. So this 1 over 4 is not the final answer. It's the value that I'll substitute here. I'll put it here, meaning that I'm now going to have -1, and this is having 2 marks. So Okay, let me finish. Then I'll say what I want to say. So we have one binary. Remember that I'm substituting this with what I've just found, which is 1/4. So now this has become my A, this has become my B, right? So using the formula, where there's A, where there's A, I'll put -1. Then where there's B, I'll put 1/4 and its power 2. So this is now -1 over 1/16, right? Okay, so if you simplify this further, you find you can write it as -1 divided by 1/16, right? Which can also be written as -1 times 16. So the final answer is just going to be, oh sorry, I didn't hold my phone properly. So I was saying that you can say that -1 divided by 1/16, right? Then which can also be written as -1 times 16 when you swap the numerator and the denominator by introducing the multiplication symbol here. So now the answer is going to be -16, right? So this is the final answer. So far you've only found this one. You've only found this, and by just showing this way, you've gotten 1 mark. Since this question is having 2 marks, so for each 1 mark, so apa nishi your lecture will even mark you some 1 mark pa. So to get the remaining mark, you need to also find the other one, which is -1 binary 1 binary 2. So this is my A, this is my B. Okay, right? So using this formula, so like I did, I'll start by solving what is in the brackets. Then when I find the final answer, I'll just come and substitute here, then continue. So where is A, I'm putting -1 over, where is B, power 2, I'm putting 1 because it will still give me 1. So my final answer is just -1. So this -1 is what I'll substitute here. So I'm going to say -1 binary 2, right? Now let me solve this one. So A is going to be -1, B is going to be 2. Using this formula given in the question, where is A, I'm putting -1. Where is B, I'm putting 2, and actually it's power 2. So it's -1/4. So we've now gotten another 1 mark. So all this week you've gotten 2 marks. This is according to how they were given marks in this paper. So let's proceed. All right, so question C, they are saying factorize the polynomial, this polynomial. Hence calculate the range of values of x for which x power 2 minus 6x power 2 less than -12x plus 8. So this question, it is having 2 parts. The first part is just this, have you seen, by just finding the factors, just the first part. The second part is finding the range of values. Okay, so if you want to find videos where I taught this, go under functions, then look for the videos titled polynomial and also the inequalities. That's where you find where I covered these things involving less than, greater than symbols. Okay, so when we find the factors, that's when we get 2.5 marks. I'm telling you about the marks because I want you to know how you get marks on the test or exam, because some of you have an issue. You know that you didn't finish showing your work, but you're expecting your lecturers to give you all the marks. Like, it doesn't work like that. Okay, I know there are lecturers who mark the, like, I don't know how I can phrase it, but there are some lecturers who only look at the final answer. That situation is exceptional, but most of the lecturers, they mark step by step. So I'm showing you how you can be getting full marks. These are the strategies students use who get everything correct. They make sure that they don't leave any marks. They get everything. every mark on each question. Make sure that you get all the marks which are there. Okay, so if you just leave this, if you don't find the range, you won't get 2.5. You won't get the full marks. So let's proceed and solve this question. Okay, so let's find the factors. So the way that you find the factors is that you are going to look at the question given. So get the number that, get the coefficient of what is coming first. In this situation, it is 1. Also get the coefficient or the value of what is coming at the end, which is -8. Then you're going to come up with actually here we are using the method called trial and errors. We are trying to look for the value which, when you substitute what is x, they have to give you 0. So this is how you don't just start guessing anyhow. So you get these values I'm telling you about. So first get the coefficient that is here, and also the value that is at the end here. This one, the constant value. If maybe at all it is there. Then now you're going to start by, you are going to start with the first value and ask yourself, which possible numbers do you think can be divided into 1 and not give you a remainder? The first value is 1 itself, the other one is -1. We can divide these into 1, they won't give us a remainder. So we continue. Then now you come to -8 and ask yourself, which values do you know, which numbers which we can divide into -8 and they won't give us any remainder? The first value is -8 itself, the other value is +8, the other value is +4, the other one is -4, the other one is -2, the other one is 2, +2 in short. Now I won't include again ones because we've already written the ones. So now you're going to start plugging one by one, but I would recommend that you arrange them like this. When you're plugging, start with the smallest ones, then like numbers increasing like that, then followed by the 4s, then ma8. Okay, so in this order, start plugging one by one on x. So like wherever there is x, so you're going to pick 1, you start with 1. You plug where there is x, you plug where there is x, you plug where there is x. Then when you simplify, if 1 is a factor, it has to give you 0 when you simplify. But if it is not, it won't give you 0. So if this don't give you, go to the next one, -1, and substitute where there is x. If it gives you 0, then it is a factor. If it doesn't give you 0, then it's not the factor. Okay, so you are going to come to -2 and so on. One of these values or more than 1 is going to be a factor. It's not always it is one value, sometimes even another value, but for the first step we just our interest is only in one value. So since in this video I don't want to waste the time trying each number, I want you to do that on your own. Okay, so the value which is going to give us 0 of these, it's going to be x. It is +2. So the value, actually these are the values of x. Yes, so the value of x that's giving us 0, when you substitute what is x in this equation given, it is +2. Now the way that you write the factor is that you write it like this. You take these 2 on the other side, it's going to be x minus 2. So this is your factor. So far you've found one factor. Okay, now with what we found, we need to find other factors. It's a case whereby the way the police do it, if maybe let's say in a certain crime 5 criminals were involved, once they just catch one criminal, that criminal will be used to catch these others. So even here, by just finding one factor, we'll use this factor to find other factors. Okay, and how do we do that? We are going to use long division. I mean, not okay. If you want, you can use long division, but the easiest one is synthetic division. So synthetic division goes like this. Make sure that the powers are dropping accordingly. So 3, 2, 1. Okay, nice one. So here I'm going to put what? This one. Don't put -2. Put the actual value of x, which is +2. Okay. Then here now we put the coefficients that are in the equation given. Only the coefficients. The first coefficient that we have for the degree power 3, it is 1. The second coefficient that is there is -6 for the power of 2, right? I mean the degree of 2. The other coefficient is 12, the other is 8. So our interest when you are dealing with synthetic division, our interests are the coefficients. Okay. All right. So I'll put 0 here. And if you don't know synthetic division, go on the A+ Academy app under functions. Look for the videos, for a video titled synthetic division. Make sure that you watch that video where I taught how to handle these questions, this method. This video is not for teaching but solving. So let's proceed. So here I'll write 1. Then we start multiplying now. 1 times 2, it's 2, right? So I'll put 2 here. -2 plus 2 is -4, right? -4 times 2, -4 times 2, that's giving us -8. Then 12 plus -8 is giving us 4. So 4 times 2, that's giving us, it's going to give us +8. -8 plus +8 is going to be 0. So with what we've just gotten, and one more thing, when you get 0 here, it's a confirmation that you are correct. This is the factor. But if when you use synthetic division, let's say you've said that a certain value is your factor, then you use synthetic division, then here you don't get 0. Trust me, it's either actually not necessary that the factor is wrong. The factor can be correct, but two of these are possible. The first possibility is that maybe the factor is wrong, or the factor is correct, but you've made some mistakes in your calculations. So if you don't get 0 here, you get a certain value. Of course, that value is a remainder, but if the value is a factor, there shouldn't be any remainder. So that means you are wrong. So check again your calculations. Maybe you made a mistake when adding, when doing the multiplication. Maybe you miscalculated. So double check your work before you proceed, because you can't leave these marks on the table like that. Go through the work again. Okay, now let's form the quadratic equation having these coefficients that we are having. So these will be the coefficient, the coefficients for the quadratic equations that we are going to come up with. So the first coefficient is going to be 1. So it's better I just write it like this. The second one is going to be -4, which is going to be the coefficient for x. Then the other one is +4. Makes sense, right? But then we have now this quadratic. We have the quadratic equation. So now remember, like I said that the reason why we found this factor, the reason why we just need one factor is to help us find other factors. So we are going to proceed by finding the factors using this quadratic equation. I think this is simple grade 12 work. Almost everybody knows how to handle this question. So the product is 4, right? The sum is -4. So to find the factors, think of the values which when we multiply them, they give us +4. When we sum them up, they give us -4. Which are those values? So these values are -2 and -2, because when we multiply -2, we get +4, but when we add -2s, we get -4. Okay, so I'm going to Okay, so now you're going to write. Now we're going to write that x power 2 minus 2x minus 2x plus 4. Factor out what is common. We remain with x minus 2. Here we factor out negative 2, right? We remain with x minus 2. Then we have x minus 2, x minus 2 as the factors. So now I want you here to be careful. We are having factors which are similar. The first factor is x minus 2. The other factor is what? X minus 2. Another factor is x minus 2. So we are having how many x minus 2s? There are 3, right? So when writing your answer, you can simply say x. First, you can list them so that you show the lecturer that you know what you're doing. Then you write and say power 3 because they are coming 3 times. They're multiplying themselves 3 times. Now, so far, you've just found the factors. So by just switching here, you've gotten yourself how many marks? 2.5 marks out of 5. So now let's proceed to the second part of the question where they said, hence calculate the rate of the values of x. Let me start on a new page. We get the remaining 2.5 marks. So if you are a student who maybe just ends here, you are in a rush, you're thinking you've gotten the whole 5 marks. When they give you your paper, you start thinking, how come I haven't gotten the 4 marks? So make sure that you're careful, okay? Okay, so the second part of the question is saying that hence calculate the range of values of x for which, now look how they have written it, for which x power 3 minus 6x power 2 less than negative 12 plus 8. So if you observe, when you get whatever is on this side, the reason why I'm talking about this is some people think it's now a different expression. No, usually they will, in fact, like 90, let me just say, whenever they bring this question, they'll bring you the same one which you've just found the factors. The same expression whose factors you found. Because we need those factors for us to find the range of values. Okay. So what you're going to do is that you're going to get what's on this side and take it on the other side. So I'm going to say, like in your solving, you need to do this. And then the video where I explained how to handle this kind of questions is on what's this? On the inequalities for polynomials. That's where you find this. So this is coming from inequalities. Then the sign will change. Observe the signs. Make sure that you change the signs when you're like bringing it here. Okay. Then here 0 will remain, right? So basically you are just dealing with this, which is the same one which we've just found, right? So the first step is you need the factors for these. You need their factors. And the factors are what you found to be x minus 2 power 3. So after finding the factors, like you've already found them, so no need to start again. Okay? So after you do this now, you need to find the region. So you are going to draw the sign table. You draw the sign table. And the sign table, since we won't like have a lot of factors to deal with, we just having one. I'll just draw like I think 2 rows. I'll just draw 2 rows where here I'll just put x minus 2 power 3. This is power 3, guys. So x minus 2 power 3. Then let me ask you this question. When we get this and equate it to 0, you're going to get positive 2, right? So here I'm just going to put positive 2. That's the only critical point you're going to have. Okay. and we just have negative infinity. Here there's positive infinity. Here we have the overall. I don't think this is even necessary. Let me just write it anyways. Yeah, so let's pick any value that can be found here. 0, right? Here let's pick 1. Okay, so if I put 0 here, I'm going to remain with what? I'm going to remain with negative 2 power 3. And as long as the exponent is not even, as long as the exponent, let me give you a trick. As long as the exponent that you are having is not something that is divisible by 2, or it is not even, the value is always negative. But if it was divisible by 2, or if it was even, it would have been positive. So the value we are going to get will be a negative value. So I'll put negative here. Let's come here. If I get 1 and I put it here, it's going to be what? No, not 1. My God. I mean, here is 2. So let's pick 3. Like the number need to be greater than 2. So I pick 3. So if I put 3 here, it's going to be 3 minus 2, right? That's going to be 1. Positive 1. Positive 1 power 3 will still be positive. So the overall will be the same, right? Now, we need to know the region where the correct answer is, between this region or this region. Let me just circle them. So what will tell us that is the symbol. If the symbol that is here is less than, it means we'll pick the region which is negative, where the overall has happened to be negative. But if it was greater than, it means that the region we're going to pick is the positive region. So the correct region is this one, this region. Let me mark it. This region here. Now you need to write your answer in intervals. So in intervals, we're going to say the range is starting from negative infinity to positive 2. Now look at the symbol that I've used here on. I hope by now, if you've watched my videos on interval notations, I say that wherever there is infinity, the symbol should always be this one. Don't use this, okay? But here for 2, what will tell you whether 2 is going, you are going to use this symbol or this symbol is this. If here on the sign that they gave you, if it was like less than or equal to, if it was like this, you wouldn't have used the parenthesis, you would have used this one instead. Okay, same applies to a situation where you have greater than, greater than symbol like this. When the symbol is greater than and they have said greater than or equal to, on the values that, on the critical points that you're going to be having, they should be part of the answers. So you should be using this whenever there is equal to. But if there's no equal to, just use the parentheses. So this is the final answer. So now you get this for 5 marks. So you get the remaining 2.5 marks. Okay, let's move on to the next question. Right. So the last question on question 1 is this one. They're saying, given that square root of 3 is an irrational number, show that this is also irrational. It is having 5 marks. So the video is actually here on YouTube, where I taught how to handle these kind of questions. So let's proceed and solve this one. So this question is tricky. I'm going to explain to you. So take note of this part and also this part, because they are like interlinked. So when I read the question again, they're saying, given that square root of 3 is what? Is irrational. So by them saying this, it means that they are saying it is confirmed. That one has been proven that square root of 3 is irrational. That's not what they want you to prove. Let me say that again. The first statement in the question is saying, given that square root of 3 is irrational number. Already they are saying it is proven. We don't want you to prove that this is irrational. No. Okay? Because it has already been proven. That's what they mean. because this question confuses a lot of students. A lot of students get confused. So this first statement is just tell that, listen, no need, we don't want you to prove that this is irrational because we've already done that for you. Now the second statement that comes, it says, show that 1 over show that 1 over 3 square root of 3 minus 1 is what? Is irrational. So now here, they are telling you now that we want you to show us that this is irrational. So when they say they want you to show them, they are not necessarily telling you that it is irrational. No. This can either be irrational or rational. It's just that them in the question, they have already assumed for you like it is irrational. But like the fact is not there. That's what they want you to do, is to prove. They want you to find, is this really irrational? Like they are assuming, or maybe it is not. Okay. Now, how do you handle this one? So we're going to contradict with their opinion, because in the question they are saying, show that it is also what? Irrational. But us, when solving, will contradict. Contradiction is where you oppose someone's opinion. For you guys who don't understand, to contradict, you oppose someone. Let's say if I'm saying, no, Messi is better than Ronaldo. Then I say, no, Ronaldo is better than Messi. Me, I'm contradicting what you're saying. That's contradiction. So we are going to say, we are proving this by contradicting. So you see, prove by contradiction. Contradiction. Okay. What are we contradicting? We are contradicting with their opinion in the question that it is irrational. So for the fact that we are opposing the idea of this being irrational, it means that as we are assuming that it is not irrational, right? Meaning that it is rational. Wait, let me write it. I show you. So we are going to say that, assume that, in my God, and before I even write anything, the statement I'm going to say here, you have to write it, but for the sake of this video, I don't want to make this video to be much lengthy, so I won't really like write it, but I'll mention it. So you need to say that, assume that 1 over 3 square root of 3 minus is rational, because we are contradicting. We are like opposing them, that this is not irrational, it is irrational. So we're assuming now. Assume that this is rational, where, is rational. When it is rational, it means that it can be expressed in form of A over B, where B is not equal to 0 and A and B are integers. So you need to write this like nicely. Okay, so you have to, and trust me guys, the reason why this question is having 5 marks is because of this statement. I think this statement on its own, it's going to have like 2.5 marks, like half of 5 it can carry. Trust me, most of the students ignore this. Even in the video I'm telling you that I've taught this here on YouTube, I explained that, right? This statement carries marks alone. With just this statement alone, I think even if you haven't solved anything, you'll get some marks. Trust me, because most of the students forget to write it. I don't know what they think. So we are going to say that, assume that this is irrational, meaning that it can be expressed in form of A over B, where B can't be equal to 0 and the values of A and B are integers and they have no factors. Then you proceed by saying, by now writing. After you write that statement, then now you say, since we are assuming that 1 over 3 square root of 3 minus 1 is equal to A over B. That's what we are assuming. So this is the first thing that you show when you start solving. So now, how do you proceed from here? So this is where the trick comes. I want you to observe. There's something I wrote this one. This statement which they first like in the question they'll tell you, given that square root of 3 is what? Irrational number. Meaning this is telling you that simplify this now. Have you seen what I'm having right now? Simplify this by just having square root of 3 as your subject to the formula. Yes. In short, this kind of equation, that's how you always do it. So observe the first statement. What is there in this situation? Square root of 3. So meaning that here we make square root of 3 the subject to the formula. So I'll begin by taking -1 on the other side because I just want to remain with what is having square root of 3. And that student who texted me that, sir, this question I don't understand. Like, come on. There's a video on this YouTube channel. Even there I explained a over b plus 1. Remember, my goal is to do what? Is to make square root of 3 the subject. I think this is where most of the students get stuck because they fail to make the square root given the subject of a formula. The one that to make the subject of a formula is the one that is in the first statement, which they have said, given that this and that is an irrational number. It can be, maybe they can put square root of 2, square root of anything. That one is the one you're going to aim to leave as the subject of the formula. I don't know how many times I'm going to say it because most of the students get stuck. Some manage to reach here, but they don't know which one to make the subject of the formula. They start making A or B the subject of the formula. No, it doesn't work like that. Okay, so let's make this side a single fraction. So we have here we have A, right? Here we have so here we have B. So right now we have 1 over 3 square root of 2 is equal to A plus B over B. Okay, no, not 3. I mean not 2, it is 3. Now remember that we need to make this the subject. So let's cross multiply. I'm using this baby class method because I know that different students are watching this video. There are those who are very good at math. Like if you're very good at math, you can just find something that you can cross multiply, like you multiply throughout, and it leaves you with the only square root of 3 as the subject of the formula. Now if I do that, most of you will be confused, like, how, sir, why have you gotten that one? I don't want to see those kind of comments under this video. So I've used this step-by-step method. So like we've just cross multiply b times 1, like cross multiply b times 1, b, that's what we're having on the left side. Then this times this, we are going to have 3 square root of 3 times A plus B. Okay, so now remember that my goal is to make square root of 3 the subject of the formula, right? So I have to divide through everything that is not square root of 3. So on this side, I'll just target to remain with what? Square root of 3, because it's the one that I'm aiming to make the subject of a formula. So I'll say over 3 A plus B, right? And we have 3 A plus B, all right? So basically, this is going to cancel. And I'm having now square root of 3 being equal to what? B over, this is 3 A plus B. And do you know the reason why I like this question? When you just reach here, like you are done solving, all what is remaining is to write another final statement which carries marks, which is important part of your work. I think when lectures are marking, they divide this question into 3 parts. This is the first statement that you have to write before you show this, that one which I was dictating to you. Then you show your work. Then also you write another concluding statement. So now, if you've been following, they wanted as to show that this is irrational. So where we've reached here, we are having square root of 3 being equated to b over 3 a plus b. So a plus b, I mean a and b can be any integers. Maybe it can be 1. Now, what we are having on the left side, it is able, it is being able to be expressed in form of a over b, right? So this means that this confirms to us that the left side is rational. How about the the right side, not the left side. The right side is rational. Then the left side, we have in square root of 3. Is square root of 3 irrational or irrational? That's where now we go to the first statement in the question. It will tell you. No need to think. Just go back. I took note of it. They said it is irrational. So by now you know that what is found on the left side is irrational, right? And what is on the right side is rational because we are able to express it in form of a over b. It is rational. Now, there's a contradiction here with what we assumed because there's no way an irrational value can be equal to a rational value. This means that what we assumed is not correct. We assumed that this is rational, so it's not correct. Listen, we assumed that this is rational. If this indeed was rational, there wouldn't have been this contradiction where irrational is equal to rational. So meaning that our contradiction, there's a contradiction here based on what we assumed. Now, this is what you have to write when you're concluding here. I don't know how you're going to use your English, but you can, if your lecturers solved something like this, maybe you can phrase it like how he was phrasing it. But whatever you use in your English, you need to state these things. So there's no way an irrational number can be equal to a rational number. This means that there's a contradiction on the assumption which we made here, where we assumed that it is rational. So this is not a rational number, this one. This is irrational. Hence we've proven. Yes, so we've proven just like that. I don't know if you guys understand the concept here. So we've shown that it is also irrational. It is not what we assumed that it is rational. Guys, if you haven't understood, trust me, just rewatch maybe this part where I've solved this question. And if you can solve this question, you can solve any question which they phrase like this. Sometimes they'll change. Maybe they'll bring maybe they'll just change. Where there was square root of 3, they'll put square root of 2. They'll give you that, show that maybe another expression which is going to have square root of 2 in it, which we need to simplify, make square root of 2 the subject, and do everything that I just did here. The mistake that most of the students make is that they will start wanting to make A or B the subject. Don't be among those students, okay? So, and another thing, show your work, write statements. First statement, very important. Your work is also very important. And the concluding statement. Concluding statements also carries marks because you need to write sensible things there. You don't just write anyhow. A lecturer will be reading. And if it is not making sense, you'll be marked wrong. That's how we get the full 5 marks that we give here. Right, so if you want to access more of our simplified video lessons, come here on Play Store, then search A Plus Academy app. This app here, you can download this app. If you don't have it, then open it. Then after you do that, you're going to create an account and log in, and then on this app now you're going to find more lessons. So just come here on videos and go maybe on term 3. Let's say maybe you want videos for term 3. You can come here and click any term 3 topic, you're going to see all these videos. And in case maybe you want them to work for physics, you can come here and you'll see more videos for momentum and work energy and power. Like everything for A levels or NS work is already on the app. Okay, so make sure that you download the app. And it's not just physics, even these other courses like chemistry, mathematics, everything. These topics, the videos are already here, and physics and chemistry, all these topics, the videos are already here. So make sure that you download the app and subscribe. All right, so let's go to question 2. I hope you've enjoyed question 1. So let's go to question 2. So question 2, they're saying that show that this is question 2a. Show that the function f of x is equal to 3x plus 3 over 2x minus 1 is bijective. Hence, find its domain and range. So this is another tricky question whereby if you are maybe rushing, you forget to find domain and range. So let's first find that it is subjective. So the whole question, it had 5 marks. Okay, so these are questions on question 2. All right, so let's proceed. So question A, we need to first, let me write what we've been given. We've been given that 3x plus 3 over 2x minus 1. So they want us to show that it is bijective. So when they say bijective, it means that this expression need to meet 2 conditions. So it means these 2 conditions have to be met. Why 2 conditions? If you look at bi, the word bi means what? 2. Binomial, 2 things involved. So 2 things need to be met. What are those 2 things? This expression, it need to be both injective and surjective. Let me write the statements for you. If you're someone who like writing statements when solving, then on this question, make sure that you do that. If you want to impress your lecturer, somebody told me that they have a lecturer whom, like when he's marking, he wants you to be like every step you need to be writing it. You need to be writing what you're doing. So if this is indeed bijective, it need to be both injective and what? And surjective. Surjective. Okay. So it need to be both injective and surjective. So when it is, so we are going to show that it is injective. We are also going to show that it is surjective. And then if it turns out that it is both, then indeed it is bijective. We are just going to say at the end that ends shown that it is bijective. So let's start. So when it is injective, let's say when injective. So when it is injective, it means that it is 1-to-1, meaning that if you say f of a being equal to, if you find f of a and you find f of b, they should give you a being equal to b, meaning that if you get the expression given, you substitute what is x with a, then you simplify, it should eventually give you a. And also if you get the function given where this x, you substitute b, then you equate them to each other. When you solve, you need to end up with a is equal to b. Let me say that again. When you get this expression, on the left side, you substitute where this x with a, like what I've written here. Then also you get this, then on the right side, you substitute where this x with b. You should eventually end up with this, a is equal to b. So let's start. So where is x, let's put a. So it's going to be 3a plus 3 plus 3 over 2a minus 1 is equal to 3b. So right now on the right hand side we substitute with b, plus 3 is equal to 2b minus 1. So if it is indeed injective, or if it is indeed 1-to-1, when we simplify this, we need to end up with this: a is equal to b. So the first step here is to cross multiply. So cross multiply 3a plus 3 times 2b minus 1 being equal to 3b plus 3 2a minus 1. Okay, so let's now multiply like we expand. So it's going to be 6a. This time this is going to be 6ab, right? This time that is going to be negative 3a. All right, so where were we? So we were this times this, right? We get negative 3a. Then 3 times this, we're getting positive 6b. This time this, we're getting negative 3b. And we come on this other side. This time this is going to give us 6ab. This time this is going to give us 3b. This time this is going to give us positive 6a, right? This times this one is going to give us negative 3. Okay, so now let's simplify. Like if at all there are those which can cancel, let them cancel. So like if you observe, negative 3 on this side is also available on this side. So this, I'm going to cancel these two out, because if I take negative 3 on this other side, it's going to become positive 3, right? And here there's already negative 3, so they are going to still cancel each other. So just see those values which like they are of the same, they are same values and having same signs. If they are appearing on both sides, cancel them out. And the first one to spot is negative 3. Any other value to spot, 6ab. Same signs, same values, right? Here we now have 3a, but on this side we are only having 3b. They are not the same. So let's just write what we are remaining with. 6b. This is b. This is the one that is 6. Is equal to negative 3b plus 6a. Okay. All right. So now what we're going to do is that we're going to make everything be on the same side. So I'm going to get what's on the right side and bring it on the left side. So here we are already adding 6b, right? Then if I bring this here, the sign will change. It's going to be positive 3b. This is going to become negative 6a. Okay, so those which can subtract each other, like the like terms. In short, let me just say arrange the like terms. So we have 3a. Let's arrange it with negative 6a. Then 6b, arrange it with positive 3b. Now let's add or subtract the like terms. So this and this both are negatives. They are going to give us negative what? Negative 9, right? A plus 9b. So let me take this on the other side. I'm having negative 9a is equal to negative 9b. Okay. So divide through by negatives, divide through by negatives. We remained with positive 9a is equal to 9b. Now recall that our goal is to end up with what? A is equal to b. So basically we can just divide by negative 9 so that we can cancel, and that we have remained with A, B. So this step alone, you've just shown that this is injective. Okay. Now the next step we need to show that it is surjective. Okay, so we are going to say y is equal to, actually let me see what we're doing right now. So right now we're trying to see if it is surjective, because we are just from saying that it is injective, right? So if it is surjective, it means that it is having an inverse. So to show that it is surjective, you need to find the inverse. How do you find the inverse? Get the expression given, y is f of x, substitute y, then write what is on this other side. 3x plus, this is how you find the inverse. You can maybe watching this video and you don't know how to find the inverse in a situation where you have this kind of equation. So sometimes they ask you a question, find the inverse of this, especially on composite functions. They like doing that. Okay, so we are going to cross multiply. We have y 2x minus 1 is equal to 3x plus 3. Okay, yeah, right. So you cross multiply, we have 2yx minus y is equal to 3x plus 3. So our job is to make x the subject of a formula. Remember, I repeat, when you are dealing with inverses, when you start simplifying like this, make x the subject of a formula. So what I'm going to do is that I'm going to gather everything that is having x in it. I'll put it on the left side. Anything that is not having x, I'll put on the right hand side. So I'm going to say 2yx minus 3x is equal to 3 plus y. Okay, then what are we going to do next? So now we are going to factor out x because we want to make x the subject of a formula. So we have 2y minus 3 is equal to 3 plus y. So I'll say over 2y minus 3 over 2y minus 3. X is equal to 3 plus y over 2y minus 3. Makes sense, right? So now, when concluding now the final, like you're concluding that the inverse is this, here's what you do. While this x, I'm going to swap with f of x power negative 1, showing that this is the inverse, then equal to. Then in the remaining expression, what is y? I'm going to swap y with x. So it's going to be 3 plus x over 2x minus 3. This is how you show the inverse. So if they told you find the inverse, you've just found the inverse. Now, on this equation that we're having, we've just shown that this is surjective. So if you've remembered, we've also showed that it is injective, right? So you can conclude that since you need to write this, since it is both injective and surjective, or in simple words, maybe you can say since it is 1-to-1 and it is also having the inverse, this shows that indeed it is bijective. So hence shown. Yeah, you've shown. Now a student who is in a rush will want to go to the next question, but this same question they have also said that hence find its domain and range. Now whose domain and range are we finding? So some of you might be confused, like, but Joseph, we have found the inverse, we are also having the original function. When they tell me to find the range or domain, which one can I pick? So pick the original function, this one. Don't get this and start using it to find domain and range. No, okay? But when finding the range, we are going to come and use this one. Finding the domain, this one, the original function. I repeat, like in case maybe you get confused in future, take note that when finding the range, we will use this one. To find the domain, we will use, listen, the range. When we talk about range, we are talking about values in the y. So we are going to pick this expression having y's, okay? But when we talk about domain, we are talking about values in the x-axis. And we are going to use this one, which is the original thing that's there in the question, the original expression that is there in the question. So let's proceed. Find the domain and the range. Okay, so let's let's find the domain. So if you remember, I said that the domain, we're going to use the original function. We're going to use the original function. So when we're finding the domain, you're basically looking for the possible values of x that won't give us undefined. And if you want to just watch like a video and actually, if you're watching this video and you have a Plus Academy app, trust me guys, there are some powerful videos I made on domain and range. You know, like you can find domain and range for any function, not just these kind of functions, but any function. And I solved a lot of theory questions. I remember. The reason why I'm saying this is because there are some students I've observed that the videos for functions, they are the least viewed. I don't know why. And they are the most powerful videos I've ever made on that application, but they are the least viewed. So I recommend that you watch this video. Trust me, you will learn one or two things which you didn't learn, because I solved every question which they can ever touch. Okay, I don't mean to advertise. I'm just like encouraging you. Yes, I'm encouraging you. Please, that knowledge is very important. Okay, so I'm saying that when you're finding the domain, it means that we are finding the possible values of x which won't give us undefined, or which won't give us 0 on the denominator, right? So what I'll do is that I'll get this denominator and say 2x minus 1 should not be equal to 0. Okay, it should not be equal to 0, because if it is 0, it is what? Undefined. Now let's solve for x. So it's going to be 2x is equal to 1 over 2 over 2. X is equal to 1 over 2. I mean, it's not equal. My God. And make sure that you're careful as well. So strictly, it should not be equal to that value, because if it is equal to that value, we are going to end up with undefined. Now, when concluding your answers, how do you conclude? So it's either you use set beta notations, roster notations, or interval notations. So let's so the first way you can conclude your answer is by saying that, let me start from here. So x, so you can say that the values of x can be any real number, but it can't be equal to 1 over 2. You even do this. If you want, you can write it like this, where you say it can be any value from negative infinity to 1 over 2, but it should, by using the parenthesis, you know that I'm saying 1 over 2 should not be part of the values. Okay, and in interval notations, this is how you write it. Make sure that here you use the parenthesis showing that 1 over 2 is not part of the values of x. Okay, now let's find the let's find the range. So if you recall, I said that the range, you're going to use that value, I mean that fraction we had in the process of finding the inverse. So as we were looking for the inverse, we happened to reach here, x is equal to 3 plus y over 2y minus 3. Okay, so to find the range, get the denominator and say it should not be equal to 0. So we say 2y minus 3 should not be equal to 0. So for y over 2 over 2, y, should not be. So y should not be equal to 3 over 2. So like we presented the answers for domain, the same way is how we are going to present the answer for range as well. So the difference is that range, we deal with y and we pick a different fraction, and for domain we deal with x and we pick the original function given in the question. So concluding the answer, you can conclude it like this. You can say y should not be, y can be any real number but should not be equal to 3/2. Or if you want, you can write in interval notations. Meaning it's going to be negative infinity up to 3/2. So let's proceed. Right. So okay, this one we are done. So all that work we've done, from bijective to range and domain, you need to do all those things to just get the 5 marks. Okay, this paper, they prepared it in such a way that for you to just get the marks, at least you have to sweat. Not simple questions there, but just do simple steps, you get the marks. So let's go to B. So B, they are saying that solve the inequality. And if you are on the app, so this question came in your test, but on the A Plus Academy app, look for the videos under functions titled inequalities. Yeah, inequalities, or let me say radical inequalities. You see there are videos where I solved a bunch of questions that has to do with this, and I'm sure a student who watched those videos enjoyed. Yeah, because the way I've taught, you can't fail to handle any question. So let's solve this question. Okay. So let's solve this question. So the first step is those values which have in x and the under a square root, we are going to find the domain. So we say domains. So you're finding the domains for them. So let's start with this one. And this is part of solving. It carries marks as well. So we start with this. So when you're finding the domain for anything under a square root, say x plus 9 is greater than or equal to 0, then say x is greater than or equal to 0 equal to negative 9. Let's all get this one, square root of x. So x is greater than or equal to 0. Then the next step is that I'll now solve for x using the initial equation given. So we have x plus 9 means square root of x plus 9 minus square root of x greater than square root of 3. So I will, only for this part where I'm solving for x, I will replace greater than with an equal sign. Then to easily solve this question, I'll take this on the other side so that here I can just remain with x plus 9. Then going to have square root of 3 plus square root of x. Then now introduce power 2 to both sides to get rid of the square roots. So here I'll remain with x plus 9. Then here on the right side, going to have 3 plus x plus 2 square root 3x. That's what you're going to get when you expand the right side. And then I'm going to take all these to the other side. Actually, this and this will cancel. So I'll just remain with 9 is equal to 3 plus 2 square root of 3x. So let me say 9 minus 3 is equal to 2 square root of 3x. Okay, 9 minus 3, that's going to be 6, is equal to 2 square root of 3x. Then let me divide by 2. I've remained with 3 square root of 3. Actually, this x is under the square root. Let me not write it like that. So yes, so something like this. Okay, so now I'm going to introduce power 2 to both sides. Here there will be 9 and here there will be 3. Alright, so let's divide by 3. X is equal to 9 over 3, which you can simplify to just 3. So x is equal to 3. Okay, so right now what we're going to do is that we are going to test the regions. We're going to draw some sort of a number line where the critical points will be these values. This value, and this value. These are what are going to appear on the number line. And then we are going to now test the region, like which region is legit. So to test the regions, we are going to be using this equation. Okay, I'll show you how we are going to be doing it on the next page. But for now, just take note of the initial equation given in the question, the critical points, -9, 0, and 3. Okay, so let's do this. Okay, so I was saying that we are going to come up with some sort of a number line, right? Where the critical points are. Recall those numbers I told you that there is 0. I mean, there's -9. I think we'll start with the same -9, then 0, then +3. Okay, so we arrange them in a way that they can appear on a number line. Now we need to find which region. Look, we have this region, we have this region. I mean, let me put -infinity here, let me put +infinity here. So we have the region from -infinity to -9. We have the region from -9 to 0. We have the region from 0 to +3, and so on. Okay, now we need to know in which region are we going to find the values. So to test those regions, we are going to use this equation which they gave us in the actual question. X plus 9, I mean square root of x plus 9 minus square root of x less than square root of 3. Okay, these are what we are going to use. And then, so the only thing that I'm going to do, I want you to take note of this. When I'm using this one to test the regions, I need to make sure that on this side, whatever is here, I should take it to the left side so that I can just have 0 here. So I should do this: x plus 9 minus square root of 3 minus x minus square root of 3 greater than 0. Have you seen? So I need to take everything to the other side so that I can remain with this one alone, which I'll use for testing now. So let's start. So pick any value that is between -infinity to -9. And pick a value which you can like easily work with. Since you don't use a calculator, pick strategically. Pick a number strategically. I repeat, always pick values strategically here. So I can pick -10. So if I put -10 here, it's going to be -10 here. It's going to leave me with -1. Here, look, the value that you pick when testing, you substitute it with x in this expression. So I've picked negative 10. So while this x, I put negative 10 minus square root of 3. So how do you know that the region is the correct region? So after you substitute like this, you need to ask yourself, if I were to evaluate these, if I were to simplify these, are they going to give me something that is greater than 0? So one trick I'll give you is, whenever you see that after you substitute with x, and you observe that there is somewhere where there is a negative under a square root, don't even hesitate. Don't even hesitate to conclude that that region is wrong. Okay? Don't even start troubling your brain to do calculations. No, this is a complex number. The moment you see that after you substitute with x, you're having a negative under a square root, cancel that region and go to the next region. So we go to the next region. So let's pick any value between negative 9 to 0. Let me pick negative 5. So I put negative 5 here. So we cancel this. This test has failed. Let's go to the next test. So again, while this x, I'll put negative 5, right? Which is going to be to leave us with 4 minus, while this x, we put negative 5, right? Minus square root of 3 greater than 0. So you ask yourself, if I were to evaluate this, can I get something greater than 0? So before you even bother yourself, check, is there a negative under a square root? If there is, don't even hesitate. Just ignore that region. It's not a true region. So we come here. Between 0 and 3, pick any value. So I'm going to pick 1. The reason why I'm picking 1 is I can easily work with 1. Like if I put 1 here, I can easily find the square root of 1. As long as what you've picked is in that range. Okay, so this test has failed. So I've picked 1. So if I put 1 here, I'm getting 10, square root of 10, right? Minus square root of 1 minus square root of 3. So this one, we don't have any square root. I mean, any negative under a square root, right? So this is where you brainstorm. So I have square root of 10. Square root of 1 is 1 minus square root of 3. 3. So you're going to ask yourself, if I were to simplify what is on this side, can I get something greater than 0? If it is true, then the region is also true. If we are not getting something that is greater than 0, then it is false. We are going to cancel that region. Now you might be wondering, now Joseph, how can I find the square root of 10, square root of 3? Because on the exam, for sure, you won't have a calculator. So ladies and gentlemen, if you're watching this video, I'm about to teach you something that I'm sure your tutors never taught you. Most of the tutors here, they'll tell you to estimate, of course. Now I'll tell you where you have to estimate if necessary. Okay, I'll show you another alternative that is more accurate than estimating. In case you don't know, there are methods you can use to find a square root of any number, even if it requires you to use a calculator. You can find its fractional form, which if you were to punch it, it will give you something that is almost near to the actual answer, or 100% near. But there are some values where it does not work, which are a few, and on most of the values it works. So you only use this method for values which you see that this one I can't find the square root using my head. But if it is something which you can find the square root using your head, it will refuse. Yes, that's the bad part. So let me show you. So we are going to pick 10. So let's find the square root of 10. So I'm teaching you something new right now. Let me even do this. So what you are going to do is that I'm going to come up with the perfect squares. So the perfect square, when you have 1 power 1 is 1. When you have 2 power 2, it's 4. When you have 3 power 2, it's 9. 4 power 2, it's 16. So based on the numbers that you are having, you can just we are just going to end here because we are not having any number that is above 16, right? But we are having one which is above 9, so I'll just end here. This is for guys. Okay, so with this method, the way that you are going to find the square root of this 10 is this. So you are going to say, of these perfect squares you are seeing, which perfect square is less than 10? Is less than what is here? Which perfect square is that? Make sure that the perfect square that you pick is not greater than 10. Something that is less than 10 and it's the closest of these perfect squares which are here. In this situation, it is 9 because 9 it is the closest. If you pick 4 and 1, it will be wrong. So pick the closest. So I've picked 9. So when we pick 9, 9 came from raising 3 power 2. So I'm just going to say 3. Okay. The reason why I've written 3 is because it's corresponding with what we've picked, 9. If you want, no, let me not say that, but you just know that we've picked this one, okay? Then we write the value where it is coming from, which is 3. Then you say plus. If you want to understand this, you can watch the video over and over again till you understand this part. This trick will help you because you know the way they bring these questions, sometimes they'll give you something that you can't solve with your brain. Then we are going to say plus a fraction. So that fraction is going to have a numerator and a denominator. Numerator is what is found on the top. So the numerator is going to be the difference between 10 and 9. So 10 minus 9, that's going to give you 1. So on the numerator, I'll put 1. Then on the denominator, you are going to get these 3 and say 3 times 2. That's 2. Then make it a single fraction. So a single fraction, this one. So making this a single fraction, it's going to give you, so let's say we pick 2 into this. No, actually, I said that the denominator will multiply 3 times 2. So it's going to be 6. So we pick 6 as the common denominator. Then eventually on the numerator, you're going to end up with 19. So 19 over 6. So the closest value to square root of 10, the closest value which is close to square root of 10 is 19 over 6. All right, so some of you might be wondering, are you sure, Joseph, this answer, is it correct? So this method is not 100% accurate, but it is like almost there. Let me show you. So if you punch on a calculator square root of 10, calculator, then let me write it somewhere here. So the calculator is giving us that square root of 10 is 3.16. But this method that we have used, if you punch on a calculator, I'm using a calculator to prove that this method is correct. So let me show you the slight difference. So this is the actual value according to the calculator, but with this method, when we divide this, we are getting 3.17. That's if we round it off to the nearest 2 decimal places. So okay, I wasn't recording, so let me just say it again. So this is the actual value of square root of 10. This is the value that the method has given us, this method. Have you seen how accurate it is? There is just slight difference. Let me, only the difference of 0.01. Have you seen? So where the numbers where this method works, it is almost there, like it is almost accurate. And this difference does not really affect the values, that like the final answer. That's why we can use it in this situation. Okay. Instead of estimating, I know some tutors like saying no, estimate. I think estimating, you're just a human being. You can't estimate, like you can find there's a big difference. But using this method, you find that the difference is very tiny and it won't affect your answer. Okay. Now there's something I want you to know. There are some exceptions. There are some values where this method don't work. So, and I'll give you how you can manage in case maybe on the exam you find yourself in a situation where those values where this method don't work, they are the ones which are there. So square root of 2, square root of 3, square root of 7, square root of 8, square root of 15, square root of 20. So if you see one of these, it doesn't work. So if you find yourself with square root with any of these values on the denominator, don't use this method. You'll be stuck. It's either you get stuck or you get a wrong answer. It produces a wrong figure. But it's just that this video is not focused on this. I'll make it, I think, another video. But there's a way you can like modify this formula to be able to find these. Now it is something that it needs to be used along with a calculator. But for now, all I can encourage you is you can just memorize. You can memorize that square root of 2, the corresponding fraction is 17 over 12. Square root of 3, the corresponding function is 26 over 15. Now listen, I know some of you are very sharp. You are like, but Joseph, these are irrational. These are irrational numbers. They can't be expressed in form of A over B. Of course, you are right. But these fractions I'm showing you, they produce the value which is like almost there to the actual value, They are not also 100% accurate, just like this situation. But these fractions, they'll give you something that is close to the actual answer, such that the answer won't be affected. I hope you understand. So these are the fractions which will give you the actual value to these ones where the method does not work unless you modify it in a certain way. So square root of 7 is 53 over 20. Square root of 8 is 17 over 6. 17 over 6. Square root of 15 is 31 over 8. Then square root of 20 is 49 over 11. So it's either you memorize these or you are just estimating, or you can maybe modify. I'll show you a modified formula you can use in a separate video. So I'll make another video showing you how you can use a modified formula, but it's going to take time right now if I start showing you. Okay, so knowing the value for square root of 10 and for square root of 3, which I've given you here, let's solve this question. So let's substitute square root of 10 with 19 over 6 minus 1 minus square root of 3. Which value is closest? It's this one, right? Which is 26 over 15. Okay. So right now your job is to make this a single fraction. Your job is to make it a single fraction. So find the common denominator. So we're going to say 6 times 15. That's going to give us 90. 6 into 90. 6 into 90 times 6 into 90 times 19. It's going to give us 285. This into 90 is going to give us 90. I mean, this into 90 times 1 will give us 9. This into 90 times 26 is going to give us 6. No, not really 6. So it's going to give us negative 156. So negative 156, 90 there. So we're going to eventually get 285 minus 246 over 90. So basically it's like we have 285, which will give us, it's giving us a positive value, which is positive 39 over 90. Now listen, our focus is to see whether the value will be positive or negative, because this value is positive. It is what we are getting when we evaluate this side. Now, if I were to ask you, is this greater than 0? This is greater than 0. Because if you look at the number line, 0 is A. Anything coming after 0, that is a positive, it is greater than 0. So this shows us that this region is the true region. Let's also test this region. Let's get any value between 3 to positive infinity. So I'm going to pick 4, because 4, if I put it here, it will easily give me the square root of, the square root of it. So now, to do the next test for the remaining region, but if you guys insist, I can make a video showing how you can find the formula you can use to find the square root for this. Even though the formula is complicated, I would recommend that you just stick to like memorizing them. This is much easier than the formula. It requires some modifications. So let's test this region. So we've picked 4, right? So where is x, I'm putting 4. If I put 4 here, I'll have 13. If I put 4 here, I'll have 4 minus square root of 3, greater than 0. So square root of 13. So square root of 13 is something that can be found. Yes, square root of 13, this method I showed you, it can work. As long as the number is not here. So square root of 13, we can use this method I showed you. So let me do it somewhere here. So square root of 13, without a calculator, you're going to find it by, have you seen the perfect squares? Which one is less than 13? It is this one, 9, right? So I'm going to pick 3 since it is corresponding with 9. So I'll pick 3 plus, then I'll say 13 minus 9, that's going to be it's going to be 4. That's going to be the numerator, if you remember. Then the denominator, I'll say 3 times 2, that will be 6. Okay, so make that a single fraction. It's going to give you 22 over 6. This is the fraction which is much closer to the actual value of the square root of 13. So here I'm going to put 22 over, here I'm putting 22 over 6. 22 over 6 minus square root of 4, it is simply 4. No, it is 2. Square root of 3, the one I told you to memorize, it is negative 26 over 15. So make this a single fraction like we did, which I'm sure everybody knows, and it's going to give you a negative value, right? Negative 6 over 90. But maybe I've made a miscalculation here, but the value you are going to get should be a negative, which is correct. So for the fact that the value we've gotten is a negative, Where were we? Okay, we were here on our last test. Let's come here. So if you check, is this true that when I simplify this side, I'm getting something that is greater than 0? Because look what I'm getting. It's a negative value, and there's no way a negative value can be greater than 0. So that means this region is lying to us. So this region is not true. So the true region is this one here. So to conclude your answer, you are, and when you're, maybe there might appear to be a lot of work here. The reason is because I was teaching you something new, but when you're just solving alone, it won't take like much of the work, because you will know that this will give me a complex number. You will know what to do. So the actual value is this one. When concluding our answers, so the range, the solutions are between 0 and 3. Now, here the way we are going to conclude the answers is going to be like this. So 0 is going to be part of the values, right? So let's move on to question C. They're saying that sketch the graph of the function below. So we have a piecewise function, and make sure that you also go through piecewise. Sometimes they can give you to just graph a piecewise, or maybe they can give you the moduluses, then they want you to redefine the modulus, okay, whereby you end up with a piecewise. So make sure that you are familiar with those kind of questions. So let's graph this. All right, so let's graph this. So we're going to start with this function here. So what we're going to do right now is we are going to first come up with the tables of values. Then based on the coordinates on the tables of values, we are going to graph this. Okay, so we are going to do this. We are going to say x power 2 plus 1. So first we are going to graph the first function, which is based on this condition. Now this condition is very important because it will help you to know the values of x that are involved, okay, and also it will help you to know whether to shade the bubble when you start graphing. It will help you to know whether to shade the bubbles or not to shade the bubble. That circle which we indicate when you're graphing. I'll show you what the bubble is. So we say x, y. So the condition, so this is the table of value of values for the first equation or function given. So we have x less than or equal to 0. So let's just put 2 columns. So the values of x, they are saying they have to be less than 0, but 0 should be part of the set or part of the values, meaning that when graphing, the bubble will be shaded. Okay, so on x here, I'll start from, so let's put the values which are less than 0. So let me start -2, -1, 0. Then to find the values of y, you get the given equation. You're going to say y is equal to, y is x, you put the first coordinate, which is -2 power 2 plus 1. Okay, this is going to give you this is going to be +4 plus 1. It is going to give you what? 5, right? So here there will be 5, and this is very important. You should know how to find y. So y, you use this equation. X, what to help you to know the value of x is the condition given here. So we come to -2. If I put -2 here on x, I'm going to end up with +1 plus 1. That's going to be 2. And here we have 0. If I put 0 here, I'm going to end up with 1. So we've come up with the table of values for the first function. So let's also come up with a table of values for this one, y minus x power 2, like this. X, y. Okay. So let's look at the values of x that we are going to have. So the condition that is given here, it is saying that the values of x should be between 0 to 2, where 0 and 2, they are going to be part of the set. So mean that when graphing, the bubble will be shaded. So we need to start from 0, right? 1, 2. So we just end here. Then let's find the values of y. So to find the values of y, you say y is equal to 1 minus x power 2. So you start with 0. If I put 0 here, I'm going to end up with what? 1. If I put 1 here, I'm going to end up with 0, right? If I put 2 here, I'm going to end up with negative 3. Okay, so slow, we are moving. So let's now come to this one. So say I have x here. So let's come up with a, okay, I don't want, let me think, do it here. So put x, y. So this will, and in case maybe you are wondering, why have I ended on negative 2? Because of this condition. Like if you want, you can even go beyond negative 2. As long as you just come up with at least the coordinates, that will help you to come up with a graph that is enough to be seen when you sketch. But me, I just like ending at the third value. If you want, you can even go as far as maybe even negative 10. So even here, it's unlimited. As long as we are starting from 2, going above, we can go 2, 3, 4. You can even go up to 5. But for the sake of time, and since even if you use 3, the graph will come out properly. So you can just end here, in case maybe you're wondering. So let's find the value of y. So I'll say y is equal to, so I'll use this one, x. If I put y is equal to x. So if I put 2 on x, what would be the value of y? It will be 2. If I put 3 on x, look, if I put 3 on x, what will be the value of y? It will be 3. If I put 4 on x, what will be the value of y? It will be 4. Okay. So now what we're going to do is that, okay, now let's graph. So based on the tables of values that you've come up with, you're going to put the numbers in the x and y axis. So let's start with this positive side of the x. So you're going to see all the values you're having which are positive in x. Which one is the largest? It is 4. So I'm going to start from 1 up to 4. 1, 2, 3, 4. And in case you're on your exam, you don't necessarily have to use a graph paper. But what you can do is when you're graphing, make sure that the space that is between each value, like from 1 to 2, 2 to 3, the gap like you maintain. If you're using a rule, I'm using a freehand, so I might not be accurate. If you're using a rule, make sure that you are measuring the distance so that the graph come out properly. Or if you're able to like approximate with your eyes, you can do that. Okay, so that the graph at least it is as expected. So in the, let's come. So on the negative side, which one appears to be the largest? It is negative 2, right? So I'll just say negative 1, -2. So in the y on the positive side, the value which seems to be the largest in the y values is 5, right? So I'll count from 1, 2, 3, 4, 5. Okay. So now let's now check in the negative of y, which one is the highest value. It is negative 3, right? So say -1, -2, -3. Okay, so now let's plug in. Let's start with this one. So we are starting from the -2 to +5, right? So it is somewhere here. So it is this coordinate, and it's going to be shaded, because the reason why we're shading is because oh no, this one is not the one you're going to shade. Not this one. The one that we are going to shade is this one. Let me draw the graph again. Alright, so I'm just going to put a small dot, like a small circular dot, not that my big one I put. That big dot is going to be put on this one. The reason why I'm going to put it here, it is presenting this 0, which is in the condition. These values, when graphing, you need to present them with a bubble, like a big bubble compared to these other bubbles, because if the bubble is shaded, it means you're saying this is part of the set, or you're saying there was an equal sign. But if there was no equal sign here, the bubble, you just do it like this, like a blank circle. Don't shade it. Okay, so let's continue. Okay, so let's now find the point to where there is -1 here to 2. So it is somewhere here. And also 0, 1. So here's where I'm going to put now, like something, it should appear to be bigger than these other bubbles. Then I'm going to do this. I'm going to connect the dots. My God. Yeah. Now, since this one, it is saying less than, right? So it can just be going like that. Okay. So let's now come to this one. So for this function, and when you are graphing, normalize label in the equation. Whenever you draw a graph, make sure that you also label the equation of that graph. So like in this case, I'm going to say +1. Now we come to this one. So we have 0, 1. So we are starting from here. Okay. So continuing from here. So this one, you're going to, it's just that we are continuing from here, but you need to draw the, you need to show the bubble, because if the bubble is shaded, let me show you something. If the bubble for this one is shaded, it means that you're saying that there's no equal sign here, or 0 is not part of the set. So if there was no equal sign here, we would have done this. We would have just done this here. Now, since there is, we'll just just continue from here. No need to. What I'm showing you is this. If it would have appeared something like this. Inside there would have been a circle that is like shaded. Then outside you leave some sort of something like this. Yes, that is if there was no equal sign. And also, even this point, we are going to also present it with a bubble to show that 2 is part of the set, and it's going to be shaded. I'm sure by now you know why I'm shading the bubbles. So ignore these dots. I'm just trying to show you how you can do it. because this question was very simple. I was expecting them to put you like in a situation whereby you also show a bubble that's not shaded, but this one, all the bubbles will be shaded. So the next coordinate is 1 comma 0, so here, right? So just take a small dot, then 2 comma 3, comma negative 3, that is here. So we need to show the bubble and it's going to be shaded. So let's join the dots. So something like this. Okay, now let's shade this one to negative. No. Oh yeah, this one we are done. So you can even indicate that this is 4. No, this is 1 minus x power 2. So let's now graph this one, which is x. Y is equal to x. Okay, so the first point is, and this one you're going to show the bubble. So for this one, we're going to show the bubble. This one here, so it's going to be 2 comma 2, then 3 comma 3, then 4 comma 4. Okay, and this even makes sense because this is a linear function just to come out as a straight line. So this one now need to indicate the bubble because we need to present this one saying that it is part of the set, and we even indicate the breaking point. Okay, so just like this, you've graphed. Right, so D, we're saying that if the root of the equation, this equation, are A and alpha B, write an equation whose roots are this. I think this is just a walkover. So if you are using the app, go under functions and look for the videos the video titled roots of quadratic equations. That's where you find alpha and beta. That's where I taught them, and also I exposed like you to a lot of questions which they can bring. Okay, so make sure that you watch that video. Okay, all right. So so this is the equation given, and so they want you to write down an equation whose roots are these given alpha and betas. So like I explained that you first need to start by finding alpha times beta, which is equal to C over A, right? Then alpha times beta is equal to, so this is our A, this is our B, this is our C. Okay, so C is negative 4, A is negative 2. So alpha times beta is equal to 2, right? And we need now to find also the alpha plus beta. Don't know if it's beta. Alpha plus beta, which is equal to negative B over A. recall that b is equal to 2. This is a, guys. A is equal to -2. So alpha plus beta is equal to +1. Makes sense, right? So now we're going to find, so recall that we are using this formula to find the equation that they want us to find, which is this one. I'll solve it quickly because this question is very simple and it's something that the majority of you are very familiar with. So this question, this equation, make sure that you memorize it when you're going to write your exam, because you can forget these equations that are here, or these formulas which are here. Even these formulas, some students make a mistake whereby they swap them or they forget to put a negative, all those mistakes. So me, I usually encourage my students whom I mentor that make sure that a day before writing maths, a day before, force, like, punish yourself. I don't know the word to use, but make sure that you force yourself to memorize all the formula. Like, try to write them down, like, without looking anywhere. Try to memorize them. Make sure that those formulas which you think that you've forgotten, go through them, then again try to memorize them. It will even improve your speed when solving, because you won't be getting stuck just trying to memorize the formula. So we say product of roots. Okay. So now this is the equation we're going to use. So we need to find the sum of the roots and the product of the roots. So let's start by finding the sum of the roots. Let me just say the sum. You know what I'm talking about. So the roots which have been given are alpha power 3, beta, it's the sum, right, plus alpha times beta power 3. So most of the students, I think, who failed this question, it was the issue of simplifying. But since this video is focused on solving, but for you guys who have access to the app, trust me, I taught some techniques which you should be familiar with, because most of the time when it comes to finding the sum and the product, you'll be needing to simplify, and some of you are not good at maths. This might be an issue. So, like, I shared some tips and tricks that you should be aware of. Okay, so the way that we're going to simplify this one is we're going to see we have this and this, right? Which one is common? Like, which ones are those which are common? We factor them out. So alpha and beta, right? So we factor them out and remain with alpha power 2 plus beta power 2, right? Now, also remember that one identity, that wherever you have this, you can substitute with alpha plus beta power 2 minus 2 alpha beta. So we are going to substitute here this to my expression. Okay, so I'm going to say alpha times beta times alpha plus beta power 2 minus 2 alpha times beta. Okay, so since we found the value of alpha plus beta and alpha times beta, the job is now to just simplify. So alpha times beta, we figure out that it is 2, right? We figure out that it is 2. And alpha plus beta, it is 1, right? Power 2 minus 2. Here it is 2, right? So when you simplify, you're going to eventually end up with 1 minus 4, which is 2 times 3, right? So the final answer is going to be 6. No, it's -6, since this one will be -3. Yes, so -6 is the sum. So negative 6 is what we're going to put here. As simple as that. And filling this question can be frustrating because this is very simple. These are one of the questions whereby once just remember the formula, it's a win-win. You've gotten everything. You've gotten the full 5 marks. And this question, I like it because the way they brought it, it was simple, and also it was not a question whereby you have to show a lot of work. And unlike these questions we are from solving, whereby to just get the 5 marks, the whole page need to get full, and the other page, like 2 pages. This one is simple. Okay, so let's now find the product. So the product is what you get when you multiply the roots which are given. So the roots which are given are alpha power 3 beta times alpha beta power 3. So like this. Now even this one you need to find ways to simplify it. So let me make it easy for you. So let's multiply the like terms. Alpha power 3 times alpha power 1. This is like this power 1. Since they are the same, powers will be added, right? So we're going to get alpha power 4, and when I multiply b times b, we're going to get beta power 4, right? Now, how can you simplify this one? And this is very simple, I think. So the way that I can simplify this is that I can also write this as alpha times beta power 4. If I expand this, I'll still get back here. So you even know that your alpha times beta is 2, right? So you just substitute 2 power 4, which is going to give you, 2 power 4 is what? 16, right? So 16 is what you're going to put here. So the final equation is x power 2 minus sum. The sum is what? Sum is negative 6. Actually, yes, then you will put x plus product of the roots is positive 16. So since this negative and negative will eventually give us a positive, right? So we're going to now have plus 6x plus 16. All right, and this is the final answer. Let's move on. All right, so we have question 3, which is the last question. So question 3, we have the first one. In this question had 3 marks. So they're saying let E means universal set, B negative 10 to 10, be the universal set. Oh yeah, they have even said it. And A is equal to this, B is equal to this interval, and C that interval. Find A complement intersection B intersection C complement. So we need to find this and display them on a number line. So the only person who will be confused when I start solving this question is somebody who hasn't watched my video on interval notation, because these were the things which I explained. Okay, so I was saying that there's a video on YouTube, even on the app it is there, where I taught interval notations. So if you want to understand anything, go and watch that video, okay? So let's take note of what we've been given. So we've been given that universal set. Let me just pause the video, right? Okay. So these are the intervals given. So they want us to find this. So the method which I'll use is the most accurate method you can use to handle this kind of questions. I know maybe there are some of you who are very good at this, that you can just look at this and come up with an answer. But it's not every student who's very sharp like some of you. Let me not even say the majority of you, because there are a few. So the way I'm going to approach this question is how I would recommend you also do. If you want to be ending up with correct answers and getting the full marks, do what I'm going to do. Okay, so first you need to find, before I even go anywhere, if you want to easily handle this question, solve it bit by bit, whereby you start with the complement, not the whole thing at the same time. step by step. You find the complement, A complement, you find its interval, then you come to A complement intersection B, you find the interval, then you come to C complement, you find its interval, then eventually you find for the whole thing. I'll show you what I'm talking about. So let's first start by finding A complement. Since you can see that A is this, right? So let me draw the number line. So I'll draw the number line. So right now I'm only dealing with, and look, if you have a universal set will be present in every number line that you'll be drawing. Universal set will be appearing. So universal set will always, the numbers in the universal set will be appearing. So they are the ones we're even going to start with, which is -10, and here there will be +10. But if we didn't have the universal set, it would have been putting infinities here. Make sure that you take note of that. Now let's put the interval of A on the number line. Of course, you're looking for the A complement, but first let's put the interval of A on the number line. But if you're very sharp enough, if you can come up with the coordinates of A complement without having to look at without having to draw this, then you can proceed. Just that this is more accurate. So A is starting from -2 and to 6, right? Since we're having this symbol, I won't shade the bubble. But since we're having this symbol, it means the bubble will have to be shaded. So I've just graphed A, or I've just sketched A. Now to find this complement is, we are basically saying in which region can we find the values which are not part of A. Okay. So starting from here, go in this direction, right? So we won't shade this bubble because 6 is already part of A. So in the complement, we don't want those which are part of A. That's why we haven't shaded this bubble. So we found one region of the A complement. The other region is this region. And actually, it is ending here because of the universal set. But if we were not given the universal set, it would have just gone to the infinity. So now, this is going to be shaded. Do you know the reason why? Because -2 is going to be part of the A complement. Why? Because this -2, for the fact that they have used this symbol, they are saying that -2 is not part of A. And that's what we want, things which are not part of A. That's why we've shaded this. So we can conclude that, this is A complement. So we have this region and this region as A complement, right? So meaning that we are going to say A complement is equal to, so the first one is from here to here, right? This region, which we are going to describe as -10. And actually, since in the universal set they have used these symbols, it means that even here the bubble won't be shaded. So we are going to use this symbol, the parenthesis, single parenthesis. I don't know if that's what we can call it, but these are called the parentheses. So we are going to start from -10 to -2. Now -2, we will use this symbol because it is going to be part of the set of, it's going to be part of the A complement, which I'm sure by now you understand. Then we say union. So we have 6 here. So 6, we are going to use this symbol because it is not shaded, meaning that 6 won't be part of the A complement. Comma. We are ending at 10, so we put 10. With which symbol? This one, because 10 is not part of the set. So you've just found A complement. So have you seen why I love this number line thingy? Like, it will give you accurate results. But if you were to use your head, unless you are very good at this, most of you will try to, but if you are very sharp, you can know. But I know it's not every student who's at that level. But if you are, then this question won't be like much of the work. So like I've said that we are going to be moving bit by bit. So far we've just covered this Kathini. Now let's cover this part, what is inside the brackets or the parentheses. So right now we're going to find what? We're going to find A complement intersection B. A complement intersection B is what we're going to find, because we already know our A complement, and B is already given. That's why. But if here there was B complement, we would have first found B complement, then we find now the intersection between these two. So that's how you should be moving. So let's sketch the number line. So you know that A complement is this. So let's start by showing the A complement. So let's put this on the number line, the A complement that we are just from finding. So likewise, there's -10, -10, and also take note of the values which are in B. There's -5 and what? And 3. So here I'm going to put -5 because it is there in B, then followed by -2, then 3, it is there in B, then here I'll put 6. Okay, so I'm beginning by putting A complement on the number line. So we put -10, we circle, -2, the bubble. So the bubble for -2 will be shaded. Why are we shading it? Because of this symbol, which is saying that -2 is part of the set. It's part of the A complement, values which are not in A. So we come to this one, 6. We draw the bubble and what? And we do this because we are not going to shade any bubble. Reason being is that 6 and 10, they are not going to be part of the set. So here we have A complement and here we have A complement. Okay. Okay, now remember on this same number line, I also need to combine B, because we need to see the region. Intersection means we need to find those, like the region where we can find values which are going to be present in A complement and B complement. So we need to put them on the same number line. So B is from where? B is from 5, so it should be here. From -5, and it's going to be shaded, right? Then 3 here. 3 is not going to be shaded. So I've just sketched B on the number line. So now let me ask you this question: in which region can we find values? In which region can we find the values which are present in both B and A complement? Is it this region? No. Is it this region? No. Is it this region here? No, because this region is only having values for B, not for A. Is it this region? No. But when you look at this region you find values which are in A complement and B complement. So ND 5 is part of the set. -2 is also part of the set. So we're going to conclude that so far we found A complement intersection B to be what? -5, -2. Okay, have you seen step by step? And the good part about this is that you'll be getting to my marks. Yeah, as you are solving, you'll be getting some to my marks. Just that this question they didn't put a lot of marks. I don't know why, because a lot of work was involved. Okay, so now let's come to this one. I mean, we've found this part. Now we need to find the remaining part. But before we do that, we need to find C complement. C complement, which is this one. So what I'm going to do is that to find C complement, okay, let me check. Okay, let me do it here. So we find C complement. The reason why I'm finding C complement is because before I find now the entire thing, I need to like find the intervals for these so that I can just easily plug them in the number line. So I'll just draw another one here. So there's -10 and here there's +10. So we are dealing with C, right? So here we are having -1. Here we are having 8, right? Okay, so that's just C alone. So let's so we are going to shade this bubble, right? Because if you look at C here, -1 is part of the set. So I'm shading this bubble, and 8 we are going to circle it, and then now we do this. Okay, so just like this. Now we need to find, so this is C. Now we need to find a region where you can find values which are not part of C. That is this one, ending at 10 here. That's where we are like ending from. So even this side, you find values which are not in C. Okay, now this bubble, I'm going to shade it. Do you know why? Because 8 is going to be part of the C complement. Why? Because by using this symbol on C, they are saying 8 is not part of C, and that's what we are looking for. So we have C complement this side, and this one we won't shade it because -1 is part of C, and we want those things which are not part of C. So here I'm going to say C complement. So let's now write that C complement is we're going to describe it as from -10 to -1, which is also not going to be part of the set, and we say union +8, which is going to be part of the set, comma 10, which is not going to be part of the set. So we've just found our C complement, which is a good thing. We've made our work easier now. So like I told you, find part by part. So we've found these ma complements, we have found them. Now let's find the whole thing. So we need to find the intersection between what? Between this and what? And this. Look what I've circled. So my focus will be on the intervals representing A complement intersection B, which is what we found here. This one. And D, C complement, which is what we've just found. So we are just going to use this and this. These are the two intervals that we are going to use. So now we can find the remaining thing, the remaining whole thing. Intersection C complement. Right? Okay. Okay. So what I'm going to do right now is I'll draw a number line. And then so it's up to you which one you're going to start with, but me, I'm going to start by sketching this one, this part, A complement intersection B, because we found that it is this one. So first let me, so like I told you that the only thing that is going to be present is this and this. So let me put these numbers on the number line so that I can just easily sketch it. Right. So let me start with this one, like I said. So A complement intersection B is being presented by 5, negative 12. So I'll put a bubble here on negative 5 and on negative 2. So both bubbles are going to be, let me check. Yeah, both bubbles are going to be shaded. So both bubbles have been shaded. So let's now also sketch this now. C complement, because we've shown this. Now let's show this one. So from negative 10 to this and negative 1, like this, the bubble won't be shaded because of the symbols which have been used, showing that this and this are not part of the set. Then we join them, so this will just be like this. Then also let's show this one as well. We shade the bubble. 10 won't be shaded because the symbol that is used, this one, is not allowing us to do that. Right. Now which region we are looking for? An intersection, meaning that we need to find a region where we can find values found in both this one, which is being presented, and actually when you sketch, make sure that you are writing. So like this one, make sure that you show them that this one is a intersection. Wait, yeah, A intersection B. Then this one is C complement, right? Yes. So we're looking for a region whereby the values which are there are found in both this and this. Is it this region? No. 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 The region is this. How can we present this region using intervals? We can present it by negative 5, negative 2. Now, what's fun is that with this question, this one is what we found here, obviously, and we found it here, but we didn't know that even the correct answer will be similar. And it has also happened to be our final correct answer. So meaning that, imagine doing all this work to just come back here. It's like you're playing snakes and ladders. The snake swallows you, then it takes you back here. So, but anyways, as long as you found the correct answer. So let's proceed. All right. So the next one is that if C is a subset of D, then this symbol means subset. Then simplify if possible. So this question, for somebody who don't understand the concept of subset, will get it wrong. I know what you're thinking. You're thinking of applying those rules, associative rules, distributive rules, all those stuffs. But for this question, the key point is on this statement. So let me explain it to you what it means. So before I even start simplifying, make sure that you get this. Right. So they have said that C is a subset of D. Do you know what that means? It means that C is like a part, is there in D, meaning that all the elements that are in C, they are also present in D. Let me give an example. So it is something like this. I want you to view it like this. Imagine you have a full set. This is C, D, right? Then you have like a small set inside this set of D, which is C. Have you seen? So since set C is found inside of D, we can say that C is a subset of D. So meaning that, suppose maybe, let's say C is having values like 1, 2. Okay, these 1, 2 are in C, right? And then D is having 3, 4. So we are in the situation where C is a subset of D, and these are the values available. So if I were to ask you, what are the values of C? The elements of C, you actually even present your work like this. You tell me that it is 1 and what? And 2. What if I tell you to tell me and actually, let's assume this is a universal. Outside, we are having a universal set. Yes. So if I tell me the elements of D, which ones are the correct elements? So for the fact that C is a subset of D, it means that whatever is in C, it is also belonging to D. Okay, so we won't just say 3, 2. No, since it is having a subset, we'll start from 1, 2, 3, 4. Have you seen? So this also shows us that when C is a subset of D, the intersection, the union between C and D will give us what? Will give us D. In case you are wondering, I'm saying that the union between C and D, whereby we unite the values found in C, we unite them with the values which are only belonging to D. It will give us D. It will give us this set. Do you get the concept? I think this is where the majority can be confused. But if you just follow the concept, you understand that it is making sense. So, meaning that as you'll be simplifying, if you happen to be where you are having C union D or D union C, what you are going to put D. Now let's simplify. So what are we simplifying? We are simplifying D complement intersection C union D. Okay, so this is what we are having. So this is what we are having. Okay, so it means as we will be simplifying, wherever we have C union D, there will be D. So let's simplify. Remember that, and actually before even going anywhere, we are having C union D here. So let's do the needful. So we are going to substitute with D. So let's multiply throughout this one. We have D union, like we are multiplying this throughout. So it will cancel this one and it will change the sign for this one and it will introduce D complement to this D. So what is D complement first of all? Values which are not found in D, right? So if you look at what I gave you as an example, where are we going to find values which are not in D? It is outside, so in the universal set. So meaning that D complement is equal to universal set. So it's like you're saying D union universal set. Now, if you unite universal set with D, what are you going to get? You're getting the universal set, right? So the final answer is universal. So just like this, you get the 2 marks. Okay, so we have this question. This is question B. They are saying resolve this one into a partial fraction. So like I said under my videos in partial fractions, they are on the A Plus Academy app. I said that whenever you have an expression like this, whereby what is on the numerator is having the highest exponent, which is larger than the highest exponent on the denominator. In this situation, you see that it is top heavy, right? Like that's what most of the people say. So in this situation, you don't just go directly and start solving. No, you don't do that. What you do is that you are going to introduce the concept of long division. Long division. So your long division goes like this. You're going to put x power 2 here, then here. And actually, before I even do this, observe the exponents. When you're plugging in this bus, I don't know if you can call it the long division formula, make sure that the exponents are dropping nicely. If you look at this one, it is like x power 2 minus 4. But what should come after x power 2 should be x power 1. So we're going to introduce it by saying x power 2 plus 0 x power 1 minus 4. So this is the one that we are going to put here. So it's going to now look like this. So this one, which is x power 2 plus 0 x power 1 minus 4, it will be our divisor. Then this one is what we'll be dividing into. And make sure that as well, for the powers for these are dropping nicely, like in order in which they should drop. If you see there is a jump somewhere, make sure that you introduce that exponent which is missing, like the way we've just done here. So we have x power 3 minus 3x power 2 minus 3x minus 5. Okay, so this is long division, not synthetic division. So if you're someone watching this video, please, when going to write your final exam, make sure that you are comfortable with long division and synthetic division. So in this paper, you are supposed to know both methods. So check there on the app, the videos are there. Okay, so what do we do now? So I'll get this one, then I'll say x power 2 into x power 3 is going to give us x. Then we now start multiplying. X times x power 2 is going to be x power 3. X times 0x is going to be plus 0 x power 2. X times negative 4 is going to be negative 4x. Let's now subtract. This minus this will give us 0. Negative 3 minus 0 is going to give us negative 3x power 2. Negative 3x minus negative 4x. It is same as having, no, let me write it. It's same as having negative 3 plus 4. That's going to be what? I mean, it is same as having negative 3 minus negative 4. Have you seen? So this will cancel, right? We have a positive. Eventually, we have negative 3 plus 4. Negative 3 plus 4. Okay. Okay, so I'm saying that it is same as having this one. So eventually, we are ending up with positive 1, right? Positive 1x. So we're going to say plus x. So let me drop this one. I'll drop it here. So we are going to have negative 5. So now let's say this into this one is going to give us, x power 3 into negative x power 3 is going to give us, negative 3. Negative 3 times x power 2 is going to give us negative 3x. Negative 3 times 0x is going to give us 0x. So plus 0x. Negative 3 times negative 4 is going to give us positive 12, right? Subtract. This minus this will give us 0. X minus this will give us x. Negative 5. Negative 5 minus 12 will give us negative 17, right? So this is the remainder and this is our quotient. Okay. So this is our remainder, this is our quotient. So the way that we do here is that you are going to say x minus 3. In short, you are going to say quotient plus So our remainder is going to become our new numerator. So our numerator is going to be x minus 17 over what over the denominator, which was initially there, x power 2 minus 4. Now at this point, what we do, I'm saying that at this point, what we're going to do is that we need now to find the partial fraction for this portion only. So when you find the partial fraction for this, when concluding your final answer, make sure that you start by saying x minus 3, your quotient, plus your partial fractions that you're going to find for this. So for now, let's find the partial fraction for this one. Okay, so for this one, and this one is very simple. When you factorize the denominator, you're going to eventually get x minus 17 over, you use difference of two squares to find the factors. So we can write the factors here. The factors are going to be x minus 2, x minus 2. I think the difference of two perfect squares is something that I've been talking about from day one. Like we've been using it everywhere. Like the concept is found like everywhere. Like everywhere it's there. Then we are going to say is equal to a over x minus 2 plus b over x plus 2. So let's multiply this throughout. You're going to eventually get x minus 17 is equal to a x plus 2 plus b x minus 2. Okay, so here we are going to say that when x is equal to negative 2, I'll use this method because it's very simple for this situation where you have these kind of factors. So I'll put where there's x negative 2. So this is going to disappear because if I put negative 2 here, I'll get a 0, which will affect the whole thing. So eventually this will be out of sight only when x is equal to negative 2. So I'll remain with negative 2 minus 17 is equal to b negative 2, negative 2. So here we have negative 19 is equal to negative 4b over negative 4 over negative 4. So b is going to be equal to 19 over 4. So let's also find when x is equal to positive 2. So I'm going to put positive 2 here. 17 is equal to a 2 plus 2. Then we are going to have negative 15 for a. Right. So we know the values of a and the values of b. So the way that we're going to conclude our answer, let me do it from here because I've run out of space. Like I don't want to go on the next paper. So remember I said you're going to begin by writing this. So we're going to begin by saying x plus 3 plus Instead of writing this, you're going to substitute with the partial fraction, which is this. So where there's a, I'm putting what? I'm putting negative 15 over 4 over x minus, no, x minus negative 2 plus, where there's b, I'm putting, this is 19. I mean, it's supposed to be 19 there. So where there's b, I'm putting 19 over 4 x plus 2. So I've just substituted. So now let's simplify it, like, let's write them properly. So when you simplify each fraction, you're going to end up with x plus 3 plus, no, actually this will even change to minus because of this negative. So you're going to, I think there must be some mistakes here. So why am I writing 5? It's supposed to be 15. So here should be 15. Pardon me, guys. So we say negative 15 over 4 x minus 2 plus 19 over 4 x plus 2. Okay, so this is the one that's going to be the final answer. All right, so we have this one. Express this in the form of a plus b, where a and b are real numbers. So this is very simple. All right, so we have this question. So the first step is you're going to expand the denominator because it's raised to the power of 2. So we are going to say square root of 3i over, when you expand this, you're going to get 1 plus 3i power 2 plus 2 square root of 3i. Okay, and then recall that I power 2 is equal to negative 1, meaning that wherever there is I power 2, we are going to put negative 1. So we have square root of 3i 1 plus 3 negative 1 plus 2 square root of 3i. So now we are going to say square root of 3i 1 minus 3 plus 2 square root of 3i. Okay, so now we are going to say that 1 minus 3 is going to be, let me write the denominator, the numerator. 1 minus 3 is going to be negative 2 plus 2 square root of 3i. Okay, so I'm going to multiply by the conjugate. So when we talk about finding the conjugate, and the reason why we are finding the conjugate is that, first of all, look at the question. They are saying that we need to leave our answer in form of a plus bi, right? And since we're having a square root, it will easily leave our answer in this format. We need to rationalize. So to rationalize, you need to multiply numerator and denominator by the conjugate. The way that you find the conjugate is you change the sign for either this or this, any of these two. I know most of you have just mastered that. You change the sign of what is here, but not necessarily. You can change for any as long as you maintain the other constant. So I'll change the sign for this one. So I'll say positive 2 plus 2 square root of 3 over 2 plus 2 square root of 3. This times this is going to be 2 square root of 3i. This time that one is going to be plus 4. No, it's not 2 there. So this times this is going to be 2. Then square root times square root, it will give us 3. Then there is I here, I've forgotten. Yeah, so I times I is going to give us I power 2, which is negative 3. Then this times this is going to give us negative 4. This time that is going to give us negative 4 square root of 3i. This time this is going to be plus 4 square root of 3i. This time that is going to be plus 4 square root times square root, it will give us 3. I times I is going to give us I power 2. So now we have 2 square root of 3i plus 6. Since this, I'll put a negative here because this I power 2, which is equivalent to negative 1, of which this is I, guys, because if you multiply negative times this, it will give us negative 6. That's why I've done that. So this and this will cancel out. Now we have negative 4 plus 4 times 3, that's going to be 12 times negative 1. So now it's going to be 2 square root of 3i minus 6 over negative 4 negative 12. 12, 13, 14. So 12, negative 12 minus 4 is going to be on the denominator. So listen, listen, we need to have the imaginary part on this other side. Look at the numerator. I'm going to swap them. Negative 6 will be this side, then the imaginary part is going to be the other side. So now we are going to have negative 6 here plus 2 square root of 3i over negative 16. Okay, so to live in this format, we are going to say negative 16 over negative 16 plus 2 square root of 3 negative 16. So 2 into 6, that's going to be, actually these are going to even cancel each other. So 2 into 6 is going to be 3. 2 into 16 is going to be 8. Minus 2 into this one is going to just leave us with square root of 3. Then 2 into 16 is going to give us what? It's going to give us 8. Okay, so now our A is what? 3 over 8, and our B is a negative square root of 3 over 8. Just like this, we are done. So in under 6 minutes. Since me, I'm doing the talking, but if I were not talking, I can solve this in less than 4 minutes or 3. Okay, so now the last question. The last question in the on question 3, application of quadratics. And so let's read the question saying that a rectangular enclosure is made against a straight wall using 3 lengths. 2 of the length given x meters each. The total length of fencing available is given by 60 meters. Show that area enclosed is given by 60x minus 2x power 2, and hence find the maximum possible area which can be enclosed. So what's funny about this question is this. So in first term 1, when they released tutorial sheet for maths, this question was there in the tutorial sheet, and I solved the tutorial sheets. I solved all of them. And these exact questions, when I tell you that sometimes they repeat questions, you are ignoring my advice. This question was repeated from the tutorial sheet, which I solved. So a student of mine who went through the tutorial sheet, I'm sure they enjoyed this. They were just memorizing. So make sure that you're taking our tutorial sheet that we are solving serious. Okay. Yeah, and they didn't change anything. They didn't. So this question is coming from application of quadratics. If you are using our application, when you go on the app under functions, you find the video titled application of quadratics. The concept that I'll be using, I've been taught there. So let's apply. So the way that I'll solve this question is that I'm going to sketch it, but I want you to like read so that you understand. But I'm going to sketch it so that you understand what they meant. And the trick that I see, this question is different from the question from most of the questions which they have been bringing on application of quadratics. This one is different from them. Anyways, let's quickly solve it. But first, let me sketch it so that you understand what they wanted you to do. Right, so they're saying that there was a rectangular enclosure that is made against a straight wall. So there is some sort of a rectangular enclosure, right? So we're thinking of a rectangle, something like this. Now, this rectangle, they have said that it is made against a straight wall using 3 lengths. So meaning that the rectangle that we are going to be using in our calculations, we won't consider all the 4 sides because they have said that only 3 lengths were used. Now, if 3 lengths were used, the other length, where was it? They have said it was against the wall. So we didn't really consider it. They are saying now that given x meters each, they're saying 2 of the lengths. So like we know that 1 length we won't use it in our calculations because like they didn't really use it to make this enclosure. They only had to use what? 3 lengths. Of these 3 lengths, 2 were given x meters. So they have used the word x deliberately, saying that one of these lengths or sides was in the x-axis, meaning that it was horizontal. So meaning that it is this one and this one. There were 3. So if we already know that 2 of them were x's, then it means that the other one was y. So in our calculations, we are going to use these. So this one won't be part of our calculations, but they have said that this was what? It was against a straight wall. So this side, we won't consider it. Let me give you a realistic example of this question. Have you seen the way it is for you guys, especially who stay Mayadi? When your neighbor has an offense, let's say this is your neighbor already has an offense. If you then this is maybe, let's say, your house. This is your house. Let's say initially your neighbor builds the offense before you do. Then maybe even you happen to have money that now you want to build an offense. How if you've observed, how do they do it? They are going to first they are only going to focus on this side, and the other side. Like they only focus on you only focus on making the fence that will only cover 3 sides, this side, and the other side. Why are we not also like building our own fence this side? Because the neighbor already did it for us. No need to do it. So we are only going to focus on this area which is uncovered, right? So we're going to only focus on these because this one, our neighbor has done it for us. There's already a fence. So it's similar to this situation. That's why they said that the other was made against a straight wall. So it's like there's this made against a straight wall which is already existing. So in our calculations, this side, we won't really use it. I hope you understand. Now they're saying that the total length of fencing available is given by 60 meters. So the lengths which are available are this. And they have given us the total length. And in mathematics, this is what we call the perimeter. So the perimeter is going to be, the perimeter is the total of all the lengths. They have said it is 60. So meaning that the sum of y plus x should give us 60. That's what they mean. So x plus x is going to be 2x. So take note of this equation. Now they're saying that show that area enclosed is given by what? 60x minus 2x power 2. This is a kind of equation whereby they know that it's going to give you this, but they just want you to show it. So they are talking now about the area. Now, what is area? Area is presented by, actually, area is width times height. In this situation, our width is being presented by x and our height is being presented by y. So basically, area is equal to x times y. So using this equation that we've just found, you're going to ask yourself, you're going to make either y or x the subject. And what will tell you that is this equation which we are aiming to end up with. So if I ask you, which one can we make the subject, so that when we substitute here, we are going to remain with values having x. Is it x? If I make x a subject, I'm going to have y, and I'll end up with values having y. But if I make y the subject, then I substitute in this formula for area, I'm going to end up with values having x. So I'm going to say y is equal to 60 minus 2x. So where is y? I'm going to put 60 minus 2x. So area is equal to x. So where is y? I'm putting what? Where is y? I'm putting this 60 minus 2x. So area is equal to 60 times x is equal to 60x minus this time this is going to be 2x power 2. Makes sense, right? So 60x minus 2x power 2. So if you compare, have we ended up with what they told us to end up with? Yes. So by just showing your work, you are correct. So the next step, they are saying that find the maximum possible area which can be enclosed. So to find the maximum area, since we know the area, I want you to take note of this one. We need to find the maximum area, like they have said. So to find the maximum area, we need to find the maximum point. If you remember, I told you in the videos on application. So when you use completing the square method, and so what I'm going to do is this. In this video, for the sake of time, I'll use a certain method of using a formula. But if your lecturer taught you this, or if you have a strict lecturer, if a lecturer taught you by using completing the square method, or if you have a strict lecturer, use completing the square method. Some lecturers want you to use, they don't like shortcuts. So make sure that you watch the video and the application of quadratic functions, where I taught out you can use completing the square method to find the maximum point. But here I'll use this formula. We are looking for the maximum value of x because we have a quadratic function now. So the formula is x is equal to negative b over 2a, because we are only interested in the x coordinate, which is the maximum. So right now we are finding x. So a is this one, b is this one. Okay, so negative b, we have 60, a we have 2, a we have negative 2, right? So now we are having negative 60 over negative 4. 4 into 60 is 15 meters. So the maximum dimension of x that should be used for us to have the maximum area, it's supposed to be 15 meters. Now, this is not what they want us to find, because in the question they have specified that we need to find the maximum area. So this is simple. As long as you know the maximum value of x, or the maximum length of x that is needed, which is this one here, all you have to do is to substitute in the actual quadratic equation. So where is x, I'm going to put 15. So I'll say find the area. So So basically, I'm just saying why there's x there, I'm going to put what? This value of x I've found, which is 15 minus 2, 15 power 2. So when you simplify this one, it's going to give you 450 meters per meter squared. Now, why meters squared? It's because that's the SI unit for area. So that's the maximum area that we need. So this is the last question in the past paper. I mean, yeah, the paper for 2025, 2026 intake. So have you seen that the knowledge that you need is there on the A Plus Academy app? So like imagine now there are some students who subscribe but they are not watching the videos on the A Plus Academy app. So if you're somebody who like not comfortable with term 1, let's say if you are watching this video and you're in your term 3, you're studying for sessional, and there are some term 1 topics which you haven't covered, like you're behind and you don't know how you are going to understand them to the level whereby you can solve any question in the past papers. Download the A Plus Academy app, you find the videos there. And also if you're in first year and you want to be able to answer everything like the way I've just answered everything in this video, also download the A Plus Academy app. I'll show you the instructions, and make sure that you subscribe to the YouTube channel. Make sure that you subscribe to the channel so that when I upload something new, you're able to access it. All right, and please guys, those who have subscribed, make sure that you're watching the videos for functions. I've come to observe that videos for functions are the less streamed when they are the most powerful videos on the app. I beg you, please, you're missing a lot of knowledge which will help you to get everything. This is why my students get everything. When I post a paper, my student has gotten 100. People think that maybe I'm just like scamming them. When literally, it's because they make use of those videos which the majority of the people ignore when they subscribe. So make sure that you make use of them and share this video to your friend and subscribe to the YouTube channel. And have a very nice day and wishing you all the best. If you're maybe studying in the last minute right now for your sessional or for your test 1, I wish you all the best on your exam or your test 1. I'm saying this because I'm assuming this video will be streamed in future by maybe a first year studying for sessional or for test 1 or maybe for deferred. I wish you all the best and leave a like on this video, share it to your friend, share it everywhere where you think it can be shared, and subscribe. Right, so if you want to access more of our simplified video lessons, come here on Play Store, then search A Plus Academy app. This app here, you can download this app. If you don't have it, then open it. Then after you do that, you're going to create an account and log in. And then on this app now, you're going to find more lessons. So just come here on videos and go maybe on term 3. Let's say maybe you want videos for term 3, you can come here and click any term 3 topic. You're going to see all these videos. And in case maybe you want term 2 work for physics, you can come here and you'll see more videos for momentum and work energy and power. Like everything for A levels or NS work is already on the app. Okay, so make sure that you download the app. And it's not just physics, even these other courses like chemistry, mathematics, everything. These topics, the videos are already here, and physics and chemistry, all these topics, the videos are already here. So make sure that you download the app and subscribe.